Okay, so good morning to all, right? Thanks to actually spend your time with us at this early morning, right? Seems like a rainy day, but then everybody is like waking up early to join our webinar here. So I welcome you to the seminar, right? And my sessions will be under the topic of probability distributions, okay? Let me share my screen here with you guys. Okay, so just introduce with you what is actually probability distribution first, right? So for your informations, there are overall two types of the random variable that we are actually study in SPM level. Okay, one is discrete random variable, and one example that we will touch into this part is binomial distributions. Okay, binomial distributions. So in the question that plays with binomial, actually they will give you n, the number of trials, right? Let's say, for example, you throw the dice for 5 times, you go and check on the books for 10 books. So all this number of trials will be written as the n value. Okay, then you have p. P will be the probability of success to get the experiment done. Okay, so we have n and p given in the questions. So we will use binomial distributions here to solve our questions. Okay, then we have the formula to find the probability in binomial distributions, and this is the one that we have here. The formula list will be given in your booklet, right, together with your questions paper. So this is actually mentioned in the formula list. So you don't need to memorize it, but you have to understand actually how to solve it accordingly to the formulas. Then we have the mean of the distributions, taking n multiply with p only, right? Take these two numbers, multiply to each other to get the mean. And then we have standard deviations, taking n multiply the p multiply the q. So p if is probability of success, then the q will be probability of failure. If let's say, for example, 20% of the students will have something, then 80% will have without something like that. So it's like a complement of each other. P is the probability of success, then the Q will be under failure. Yeah, Q is failure, probability failure. Okay, and normally if you see the graph for the probability distributions in binomial, you will get the information in a bar chart like that or a line chart like that. They are independently given in individual values. Yeah, there's no connections between the numbers. It's like individual values. Yeah, one by one. Okay, and the total probability, we know that is always 1. Yeah, probability is always 1. Okay, this is the first distribution we have, binomial. Everything will be counted in whole number. Yeah, for your information, things will be counted in whole number like 0, 1, 2, 3, and 4 like that, right? Whole number. But when we come to the continuous random variable, right? Continuous random variable, we will have the information given as decimals, right? Or fractions form, decimals or fractions form. Okay, so these informations, we will use some formula to solve it, but in SPM, we will introduce you with only normal distributions, yeah, normal distributions. So the way that we compare to what we have here, in binomial, we have n and p, right? Number of trials, how many times you try, and the probability of success, okay? But in normal distributions, we will give you the mean and the variance, yeah? In normal distributions, we give you the mean and variance. And this is a conversion we will use because in the SPM question paper, they were attached with one statistical table, which is standard normal, right? And that value is actually need to be used to actually find the probability for normal distributions. Yeah, so we have to convert the Z, right? Convert the X distribution to Z using this formula. Yeah, we convert the X to Z using this formula. Okay, then this will be the graph we have, right? If you look at your statistical table given in your questions, and this is the table, we will show the area for the probability given in the questions, yeah? Okay, so for your information, this topic is actually considered quite important because it will be asked in the paper 1 under compulsory section, right? You know that paper 1, they are all questions compulsory, right? And there will be 1 or 2 questions asked there. Yeah, 1 or 2 questions. Then in section B under paper 2, yeah, paper 2, there'll be 1 question asked under section B for these questions. Under the sections B, answer 4 questions from the 5, right? So if you know the way to answer these questions, I can propose or suggest you to answer this, because the way of answering is not difficult. As long as you get the idea of binomial and normal, you can actually get full marks for the full questions. Okay, so we'll go through the question that we actually shared with you earlier from the Zoom, right? Okay, then from there we will see how we actually answer the questions one by one. Okay, let me go through the discussions with you here. So the first question that we have, right, we have mentioned here, for the probability distributions given for X, it follows binomial, okay, where total of 5 trials. So that's why you see in my graph here, I have from 0 until 5 here. The 5 here will be the maximum trials, but the X value can take starting from 0 until 5. That's why this is the overall graph you will see for the X distributions here. Okay, then the question mentions for X below or equals to 2. X below or equals to 2 will be 0.68. So if I refer to this diagram, 0.68 is actually applied on those below or equals to 2, meaning I will take either 0, 1, or 2. So these 3 add up together will give me a probability of 0.68, right? So I will form the first equations. Equation 1, we will say that the first value, I have 0 with P probability. Then I have 1 with Q. 2, I have 2 also. So I will have the first equations to be P plus 2Q, right? P plus 2Q is given as the one mentioned here, 0.68, yeah, 0.68. From the question I have, these 3 bars add together, the probability is 0.68, okay? But actually, as we said earlier, total probability is always 1. Yeah, you add everything together, it's always 1. So if you tell me that these 3 bars is 0.68, meaning the balance here will be 0.32. The balance part here will be 0.32. This part is 0.68. The balance part should be 0.32. So I will add the balance 3 here. The first one is P, second one is 0.1, and the third one is 0.06, right? These 3 bars to be added together, and the total is a balance 32. So I have 2 equations to solve here and get my P and Q for this part A and B, right? So I solve my equation 2 first, because these equations only place with P, yeah? So from the 2, okay, from 2, I will have P plus 0.16 is 0.32. So it means what? I can just solve my P easily, move this over, right? I will get this answer as 0.16 directly. So this is the answer for part A, okay, part A. Whereas for part B, as we said, we still have equation 1 to be solved here. So to solve further, I will check for the equation 2, sub these 2 into 1, right? The 1 from the 2, you solve this. Then I sub these 2 into the 1. I will have 0.16 now plus 2Q as 0.68. Yeah, because from the 2, you get this P value as 0.16. From the 2, you get P as 0.16. You can replace into the 1 here, 0.16. So 2Q will give you 0.168 minus 0.16, right? And this will be 5.2, correct? 2Q. Okay, and of course, you can solve it further using calculator. This will give you 2.6. Okay, question 1 paper, right? Question 1 in this normally will be asked in paper 1. The question will be quite direct. Either they show you using graph method, or you can just see directly and solve it accordingly. The questions will be considered direct questions, yeah? Direct questions. Okay, this is my first question with you. Then we go to the next one. So in this question 2, right? In the question 2, we are given that 85% of the patients will recover after taking the fever medicine. Okay, so I will now try to let X, because I'm going to use X to represent my notations here later. So I have to label what is my X first. For example, let's say I let my X to be the number of patients, right, will recover from after taking the medicines, yeah, I will just mention the X refer to the number of patients here, okay? And then after that, because they give me this probability as 0.85, 85% means 0.85 as a probability here. And then total patients I have here is 8 numbers, right? 8 patients. So in this question, you see that they give me n as 8, then the p as 0.85, right? So I can actually say that this X follows a binomial distribution. The n here is 8, and then the probability for those recover is 0.85. I will have this probability with me and the n as 8 patients. Yeah, 8 patients, probability of success 0.85. So in the part A, right? Let's see part A. Probability that 5 patients will recover. So remember just now we have a formula for probability. This is the probability formula, right? Okay, but in the questions, they just want to find only 5 patients recovered, right? Only 5 patients recovered. So the X here refer as 5. Okay, the X here refer as 5 and the N here refer as 8. So I have N8, right? Probability here as 0.85. Then the X, small x here is 5. So I will just put down my notations here. Question asks to find X equals to 5. This will give me 8C5, yeah? 8C5. Then multiply with probability of success I have here is 0.85. So the power follows the X value, which is 5. Then I have 0.15 followed by the balance power, which is 3. Okay, just go with the formulas. Remember, N given as 8. Question asks for 5. P is 0.85. But remember, Q will be the failure rate, right, compared to the successful rate as 85. Then I will have here balance as 1.5. So use this formula. I believe that you can get the answer as 8386. Okay, na? Next one, okay, next one, I have the question asked on mean, yeah, asked on mean. So for the case that you have earlier, we say that there is one formula for the mean, right? Mean will take n multiply with the p, n multiply with the p. So these questions, my mean is 8, my probability is 0.85, yeah, my probability is 0.85. I just take 8 multiply 0.85 to get the mean value here. So the answer will be just 6.8, yeah, direct questions. So all these paper 1 questions under these sessions, right, they will ask very direct. Just substitute formulas and get the results, okay? Now for the part C, standard deviations, right? Again, we have a formula for standard deviations. For those recovered, so we will have standard deviations will be square root n as 8, probability 8.5, right? Then I have failure 1.5. Just replace to the formula and we will get the answer. Okay, so all these questions will be direct. You just see the basic N and P. You should know what is the Q. So see what the question wants, substitute into the formula only, right? So that's why I say if you can get the picture for this, it's good to actually answer these questions, yeah? If you have a chance to look at the paper 2 later, right? Okay, now let's look at this question 3 here. Question 3, we have this probability 20% of the students drive to campus for their class, right? Now I take 5 students, you see that? The N is given as 5, N given as 5, okay? N as 5, P is 20%, 20% means 0.2, okay? So you have N and P given again. I will say that this one will follow a binomial distributions, yeah? So one more time, we let the X first. Let the X be the number of students, right? Drive to campus. All right, you label down what is your X first, because I'm going to use X for my notations here later, yeah? Okay, so you label down what is your X first. So now X, as I see here, it follows binomial distributions. The N we have here is 5, right? And it's 5 people. And then I have probability for those drive to school is actually 0.2. I just put here 0.2. Okay, just put in the normal form like that. And now I'm going to start answering the questions. Part A, probability for all 5 students. So all 5 here means they refer x as 5 also, right? The small x as 5. So again, I use a formula for the probability in binomial. I will say that question asks for 5 here. Question asks for 5 here. So I have 5, C5. Probability of success is 0.2. I will just put here 0.2. Then power follow x. If 20% drive, 80% will not be driving. So I will have the balance 0, right? Power will be 0. Okay, and you solve it out. And I believe that the answer will be this, yeah? This 0.00032. Okay, question will be quite direct here if they ask only a probability for one number. Okay, let's see for part B. For the part B here, question say they want to find at least three. Okay, so for those at least 3, when you write out as notations, you will use the symbol greater equal, right? At least you will use the symbol greater equal. Okay, remember we have maximum 5 members just now, yeah? We have maximum 5 members. So you start counting from 3, right? You want at least 3 until maximum 5. So therefore, I can list out one by one. I will say that I will take the probability of 3. I can take the probability of 4. And at the same time, I can take the probability of 5. Yeah, because maximum number that you have here is 5 members. So you can start counting with what you want from the questions. Question says that you want at least 3, right? So you start counting from 3, then you go until 4, then you go until 5. Yeah, maximum is stopped at 5. So you go with the formula again. For the probability, we have 5C3, then we have 0.2 to the power of 3, 0.8 to the power of 2. Then we continue, 5C4, 0.2 to the power of 4, then 0.8 to the power of 1, and the final one, 5C5, 0.2 to the power of 5, then 0.8 to the power of 0. Okay, you list out one by one, and then you add these 3 answers together. Yeah, so this will be the answer for B. So I just copy down my answer there, 0.05792, right? So normally probability questions, if you can just give in 4 significant figures, right? 4 SF, yeah? Okay, this is for question part B. Sometimes the questions in probability, they just want 4 decimal place. You can actually see what is the needs by the questions. Normally you can give 4 SF, yeah? 4 SF. So this is for part B. Okay, let's go to the next one. Yeah, next one, long questions. So long questions will have a story given normally, then they will ask you to find more things here, Okay, let's see. In Malaysia, 70% of the days in October are rainy day, right? Find in a week only, right? They don't find for the whole month, but they only find in a week. So 1 week, we know that we have 7 days only, yeah? For those, you know, 1 week, we have 7 days. So let's say for the end here, I know that it's only 7 days. This will give me the probability here as 0.7 if I refer to the questions of rainy day, right? So one more time, I will just mention what is my X first. X refers to the number of rainy day, let's say, okay, in a week in October, let's say, right? So one more time, I can say that it will follow like a binomial distributions. The n is 7 and the probability of success is 0.7. Okay, you have 7 days in total for a week, then you have 70%, which is 0.7 for the P to put into the binomial distributions. Okay, so now in part A, let's see. The probability that every day in a week is rainy day. Every day. So you know that every day means they refer the X here as 7, yeah, the small x as 7. So again, use the formula for probability. I will have P X equals to 7. All the 7 days are rainy day, right? Then you have 7, C7. Then you have probability of success, power 7. Then probability of failure, power 0. All the 7 days in a week, right, is actually a rainy day. So you put here 77. Probability of success to the power of 7, then failure to the power of 0. Okay, this is quite direct. You have the n, you have the p. Just put into the formula with the x value they want to find here as 7. Okay, now part B. Find the mean number of days, right, which is rainy day in the week, mean value. So we know that the mean will take n multiply p, right? So I will take here, the mean value will be, I have mean here as 7 multiply 0.7. Just take your n multiply your p. So you get this as 0.7 multiply 7 to give you 4.9. Clear cut. Okay. And then the part C here. So for the part C, right, question asked also on probability, but they want to find the probability that the number of days, rainy days, right, is more than mean. I found this as my mean. So meaning I will actually write this as Px more than mean means more than 4.9. Yeah, I want to find the probability for the number of rainy days in the week, right, is more than 4.9. But we don't count the days here as 1, 2, 3, or 4 or 4.9 like that, right? We have to count as whole number. So therefore, this case, we will put it as this. Instead of 4.9, I put as greater equals to 5. Yeah, greater equals to 5. Because 4.9, for those more than, I will start counting from 5 onwards if I consider whole number. Yeah, because the number of days here, we count in whole number one by one, right? So we will put as 5 onwards, 5 onwards. But we have total of 7 days here, total of 7 days. You are checking for those greater equals to 5. So this case, again, one more time, we list out into individual term. We have to start from 5, add with 6, then add with 7. Yeah, the maximum we can stop at 7 because the total number of days in a week here, that is only refers to 7 days, yeah? So we can only stop at 7. So by using formula of probability one more time, we have 7 C5, then we have 0.7 to the power of 5, then we have 0.3 to the power of 2, then we have 7 C6, 0.7 to the power of 6, 0.3 to the power of 1, then we have the last one, 7 C7, 0.7 to the power of 7, then 0.3 to the power of 0. Yeah, we add these 3 together to get the final answer with this. So remember, in binomial distributions, the things that we have, we count all in whole number. So if the questions ask you to find something which is greater than a decimal even, we have to see from whole number. Yeah, we have to see the answers in whole number. So that's why we change this into this form. Then from there, we list out the terms that we want to find. Okay, that's the idea. So remember, binomial always give you n and p. From there, you see either you want to use the formula for probability, or you want to use the formula for mean or variance. Then from there, you solve it accordingly. Okay, it's not so difficult. Questions are quite direct. Yeah, it's worth to answer in this part. Okay, now let's look at the next one. Next questions. Given a discrete random variable x follow binomial, right? So it gives me that the x follow binomial, I will have this thing with me, right? And p. Okay, the mean given is 1.8, then the variance is 1.26. Mean is 1.8, variance is 1.26. Okay, let's go back to the formula for mean. This is the mean formula, and this is the variance formula, right? Remember just now we have sigma as square root and PQ. That is for standard deviations, right? Standard deviations. So if we move the square root over, it's like we square both sides, we have this as sigma square S and PQ, yeah? Just square both sides, we will have sigma square S and PQ, correct? So therefore, in this case, I will try to write one more time. NP by the questions here is 1.8. So I have this. NP is the mean. I have 1.8. Yeah, I just put it down. Variance is actually, as I said here, by using the formula, I have NPQ. And the value is 1.26. Okay, so you have these two equations with you, equation 1 and equation 2. So now you want to solve the P, and also N, right? So to solve this part, normally we play with simultaneous equations, of course, right? We can replace this NP as 1.8 into the second equations, correct? NP itself is 1.8. So this part itself is 1.8. Multiply with the Q is 1.26. Yeah, you sub in the first one into the second one, right? Then you have this NP whole thing as 1.8, you put into the place here, 1.8, then you have Q equals to 1.26. So you can solve it further, 1.26 divided by 1.8, I believe that will give you 0.7, right? 0.7. Okay, 0.7. But this is not something requested by the questions here. Question asks to find P, right? But we know that if you know what is Q, yeah, if you know the failure percentage, then you should know the successful percentage, which is P, correct? P is always the complement of Q. You take 1 minus. So this will give you 0.3, clearly, right? Your P will be 0.3. Okay, so we have solved the part A. Now the part B. How do you find N? How do you find N? N, we can actually put it back my answer for this, right? Let's say I take this as equation 3, P value is 0.3 as third equations, right? I substitute into my first equation. Let's say I sub this 3 into my first equations. So I have NP as 1.8 now will become N multiply 0.3 as 1.8. So my N will be 1.8 divided by 0.3, which is 6. Okay, so this is direct. You can actually find the N easily using the equation 1 only, right? So N is done, 6. So meaning now my X will have a binomial distributions. N is 6. Then the probability of success is 0.3. I have this with me. So in part C, we are requested to find X below or equals to 2. So this one is like the normal case. We find using formula for probability. We have Px lesser equals to 2 takes the value. Lesser equals will start counting from 0, the basic one, until 2, right? So I have 0, 1, and 2 to be added together. So for those with 0, I have 6C0, 0.3 to the power of 0, then 0.7 to the power of 6. Plus with 6C1, 0.3 to the power of 1, then 0.7 to the power of 5. And the last one will give me 6C2, 0.3 to the power of 2, then 0.7 to the power of 4. Yeah, just add them together to get what is needed in part C. Okay, so remember in the binomial distributions, clear cut, they should tell you what is your N and what's your P. Or else they will give you some hints like this question 5. They give you some hints here to find what is your N and P and apply it in the later part. Yeah, so binomial distributions will give you a clear cut. N and P must be known, right? Or must be able to found from the questions, yeah? N and P should be known or able to found in your binomial distributions here, yeah, questions. Okay, this is for binomial. Now we look at the second type of distributions. We have normal distributions, yeah, normal. So for normal distributions, as we said, we need to refer the statistical table, yeah? The statistical table normally give you a normal curve like that, right? Whatever given value from the table, sorry, it should be at the center, right? Whatever table value given is actually refers to the end side, either in the left or right, yeah? It should be at the end side, the end tail from the distributions. Okay, so let's take a look on this. We have X follow normal. X follow normal distributions. Mean is 52, right? Mean is 52. Standard deviation is 8. Okay, but remember when we go for this, we always write out the way of mean and variance. So therefore, even though questions give you standard deviations, you put as 8 square like that, because I want to see variance in my writing here. Okay, so now in part A, in part A, they are looking for X score when Z is 1.2. So remember just now I told you there's a formula to convert X and Z, yeah? There's a formula to convert the X and Z. So we have this with us. So if your Z is 1.2, your X is unknown, just put X. Your mean value is 52, and your standard deviation is 8. So you can actually play with some simple algebraic functions, right? Play up and down like that, and solve it. What is your X? So your X will be 1.2 multiplied 8 plus with 52, right? And you should get the answer as 61.6. Yeah, just use the formula for the conversions here to get the X value. So remember the difference between the X distribution and Z will be the X normally has its own mean and also own variance. But for Z, the mean is always 0 and the variance is always 1. Yeah, for Z, you have the mean as 0, variance as 1. Okay. Next one, in part B, right? Part B, find the value of A where X more than A is 0.0778. Okay, so this is something that we mentioned, probability here. So this probability is actually refers to area given in your Z distribution just now, like here, right? They give you a normal curve. Let's say, for example, if this is a normal curve, this is a Z distributions, right? I do not know what's the value, but the area given there is 0.0078, yeah? So this is the area, let's say 0.0778, okay? But what I see here is Z. What I see here is Z. What I have here is X. So therefore, your first step of doing, you must actually convert, right? You convert, okay, from the X distributions to the Z distributions. Let's say here, you change the X to Z. Change the X to Z. By how? This is the formula, right? You take your X value, this is considered as X value, minus the mean over standard deviations, yeah? Over standard deviations, 0.0778. Okay, take your X value, which is A for this round, minus the mean over standard deviations. Then this probability is the same with the one given in the graph here, 0.0778. Okay, so now I need the help from the graph, right? The distributions. Okay, so this is a table as I mentioned to you. It should be given in your questions paper attached at the back page normally, or the front page like that, right? Okay, depends on the arrangement. So we have to see, remember what is given inside here. All this inside here refers to area. This part refers to area or the probability. Yeah, whatever given inside here will be the area of probability. Whatever given outside here, the column for this and this, right? All this outside column, they refer to Z value. Okay, the Z value. Okay, so now we have to find what is the answer for 0.0778 just now, remember? So we have to see what is the locations. For that, we found this is a place, 0.0778 located here. And we want to also find the Z value, right? Z value here will be 1.42. So the Z value that we have here is 1.42. Based on the probability with this, the Z value we have from the table here is 1.42. Yeah, Z table shows us 1.42. Okay, so go back to my slide just now. This value is 1.42, right? 1.42. So if I do a direct comparison, my table show me more than 1.42, the probability is also the same, right? So it means what? The inner part here have to be the same. Means A minus 52 divided by 8 must be 1.42. Yeah? Compare what is given inside with the probability same for both. I will have this expression to be simplified here. A minus 52 as 8 multiply 1.42, and my A later will be, take this answer plus with 52, right? Then you can simplify to get 63.36. Okay, the value of A will be just 63.36. So remember, you will need the table just now to actually get the regions and then find the corresponding answer for Z to compare with the notation you form here. Yeah, to solve those questions, the additional part we have to refer is actually the table form. We don't need to calculate by ourselves like binomial. We have to calculate the probability using NCR formulas, right? But this case, we don't need to calculate the probability using formulas, but we just refer the table or statistical table values here to get the area or probability for the questions needed. Okay, that is for the part here. Now we go to the next. Yeah, this one we have done. Okay, we go to the next one, question 7. Yeah, question 7. So in the question 7, told by the question, this is the graph for FZ, right? Already in terms of Z, okay? And they say to me, this arrow shows the directions of area. Yeah, where is your area? It's actually at the left-hand side, yeah? Point to the left means your area at the left-hand side here. This left-hand area is 8577. Yeah, the area at the left-hand side here is 0.8577. Okay, what I tell you earlier was actually the area given for the table that we have, right, attached in the questions there, is actually at the end side here. Remember, the area given at the side is actually refers to the end side. So I can't find this from the table, but I can find the opposite side. So therefore, I will take 1 minus this, 1 minus 0.8577 to get this area here. This will give me 1423, right? 1423. This area will be 1423. Okay, so now I will need the help from the table just now. Go back to the same table, find 1423. And I believe that this is the locations, right? These are the locations. So from there, you can see that the Z value point at 1.07, 1.07, yeah, 1.07. So meaning what? In my diagram here, this K value should be 1.07. Yeah, that's why your K here directly will just give the answer as 1.07. Okay, so you can show the answer for this part balance here as 1423. Then you refer to your table just now, the statistical table, and get the K value, and then just put down your conclusion, K as 1.07. Okay, this is the one. Now go back to the part B. Go back to part B. Okay, same graph you applied, but here they tell you that more than K. So remember just now it's lesser. Now they say more than. More than K is 0.15, means this round, this part is 0.15. The part given here is 0.15, okay? But you remember the graph should be symmetric for both sides. Yeah? The graph is actually symmetric for both sides. So now I want to see what is the meaning for this. So for informations, if you see the probability of modulus Z below a K, modulus below, this actually shows answers in between, yeah? The answers for modulus Z below should shows in between, means what? It should take this to change to another inequality that we used to see, which is negative K, Z, and K, right? So remember, if you see modulus lesser, your answer will change to in between positive and negative, right? So negative K to K. And now let's take a look. If let's say my graph for this, I want to draw another line here, which is negative K, right? Negative K to K. And they want to find the answer in between, meaning they want to find the regions here. So remember just now we say the graph should be symmetric for both sides. If your right-hand side for K here is 0.15, it's understood that this balanced part here is also 1.5, correct? 0.15. So to find the answer in between this is actually taking 1 minus 2 balanced answer outside, 1.5, correct? So I will have this as 0.7. Yeah, clear cut. So questions in paper 1, they will use very simple idea for the formula, like either to see from the graph itself or to just find from the statistical table we have, but very simple idea. You can find directly from the table and solve it accordingly. Okay, not much formula on that part, on this part here, but you need to find the answer from your table. Okay, whereas for paper 2 questions, paper 2, they will give you a story. Yeah, they will give you a story. Like this case, they give you a story. From there, you have to form your own mean and variance and solve your questions accordingly. Okay, let's see what we have here. The mass for the chicken from a farm, right, owned by Mr. Russell, follow a normal distributions. So again, you can let what is your x. X refers to the mass of the chicken, right, owned by the farm, for example, right, owned by Mr. Russell, for example. Okay, so x, for this case, they tell me it follows normal. So I just say that, okay, it follows normal. I put down normal. Yeah, and the mean here is 3.25. I will put down mean follows by variance. Be careful on this. When you play with the functions here, make sure the units you use, they are all the same. If you put here with kg, this part, make sure you change to kg as well. Yeah, change the 400 gram to kg. So you have 0.4 kg, right? So this part will be 0.4 square here. Okay, standard deviation is 0.4, but when we play with the notations for normal distributions, this part should put as variance. That's why I put my answer as 0.4 squared. Okay, what is the next term? They say, those chicken more than 2.8 will be sold in the market. Those more than 2.8 will be sold in the market. So now they want to find probability for those chicken sold in the market, right? It's like they're asking you to find x for the weight, which is more than 2.8 kg. They want to find this. What is the probability that for the x, right, that given in the questions here, has a weight more than 2.8 kg? Yeah, then this type of category of chicken will be sold in the market. I want to find this probability here. So as usual, x, the first step, I need to change this x into the z, yeah, into the z. Change your x into the z, yeah, change this x into the z. I have to use the formula. Just now we say, take the x value minus the mean, then over standard deviations. Okay, take your x value minus the mean over standard deviations. Okay, so let's see what you have here. Okay, I believe that you get this answer as negative 1.125, right? 1.125. Okay. And normally after this step, right, myself will actually try to draw out a normal curve to show a better idea how to get the answer from the table. So let's say after the step for this, after I get exact terms here, I draw a normal curve. Okay, just a sketch only, no need to be so perfect. Oh, so bad, shaking non-stop. Okay, so I will have this normal curve. Remember, 0 should be at the center, 0 at the center. Negative 1.125 is a value located in the left-hand side because it has a negative value here, yeah? Okay, negative 1.125. Okay, this part, they refer to the directions of the area, remember? They are asked to find greater side than this. So I'm actually looking for the area at this side here. Area for more than this value. So this is my z value, remember? I'm looking for this area. But we can't actually get this answer from the table directly, as I told you earlier, right? This one cannot be found from the table directly because the answer only allows us to go until 50%. Okay, so therefore, in my table, I find the opposite answer here first. And then I take 1 minus. Yeah, take this answer first from the table, then we take 1 minus. Okay, let's see what we have for this 1.125 first, yeah, 1.125. Okay, 1.125 is actually from 1.1, 2, and 5 here, right? Okay, you get this here. So you should take this answer, the answer that you have here, take this answer minus the answer you have here. Yeah, take this answer minus 10. So you minus 10 from the back here, minus 10 from the back. You have this as 1304. Okay, so the area given at the right hand side here give you 0.1304. So that's why when you come back to this area, the left hand area here is 0.1304. Left hand area here. So to find the balance, to find this balance, we take, as usual, 1 minus the table value. Okay, 1 minus table value. So this will be 8696. Okay, 8696. Okay, so remember when you have the questions with this, we always change the x into the z, change the x into the z, right? By taking the value of x minus the mean over standard deviations. Yeah, over standard deviations. From there, we find the z value. We find the z value. We draw this graph out, prefer table value, solve the probability. So this is the normal practice we do. Yeah, okay. That's why it's good for you to write this down so that you know what is the mean and the standard deviations here. Okay, let's look at the part B now. Part B. If there are a total of 250 chickens to be sold in the market, right? How many chicken in total in the farm? How many total chicken in the farm, right? Okay, so let's go back to the basic probability questions here. Basic probability. Normally to find probability, let's say probability of A, we take total of A we have over my grand total, right? That's the normal way we do, yeah? Take the total I want over total, grand total, okay? So the probability I found in the part A here is 0.8696, so I just replace it. Probability I found is 8696, I just put it here. But I do not know what is the total I have in the farm, right? Okay, total of the chickens sold in the market is this. So I have 250 on top, but the total, I do not know how many in the farm. So I do not know what is my NS here. I'm looking for NS. Therefore, to find this further, the NS will be taking the answer for 250 divided by 0.8696. Yeah, just swap these two places over, right? Move the NS up, move this down, then you have this to get the answer of 287. Yeah, I just copied down the answer, 287. Okay, that's the way to solve the questions. Go back to the basic idea for probability, right? We have NA over NS. So this 250 will be the one sold in the market, right? So I will just have 250 on top, and the total of the chicken in the farm is unknown. I just put at the bottom as NS. So swap the place to find the NS here. Okay, this is for questions 8 part B. Okay, 2 more questions to go. Okay, so now let's look at question 9. Yeah, question 9. So for question 9, we have the time taken for a postman to deliver the mails in the Cheras area, right? Mean is 15. Standard deviation is 2. Okay, so for this, again, we try to list out what is my X notation first. For example, let's say I try to denote what is my X first. Let X define as the number, no, should be the time taken, right, to deliver the mails, right? Okay, the time taken by the postman to deliver the mail. Okay, and the X here follows normal, right? The mean is 50 minutes. Standard deviation is 2 squared. Okay, so I just put in the form like that. Okay, now in part A, what they want to find? probability, right? Probability. So I just write down in the notations for probability here. They want to find P of 10 x until 12, right? They want to find this. Sorry, they'll find this. Okay, but as we say, the x is just a general one. We always have to convert this into the z distributions. We have this as 10 minus the mean, right? Remember the way of conversion is here. Minus the mean, we have 15. Then standard deviation is 2. Once I write these notations here, minus and divide, this x will change to z here, just for information. So I have 12 minus 15 over 2. Then I have it as minus 5 per 2. This is minus 3 per 2. Sorry, this is 2. And I will get this as 2.5 and 1.5, right? So I have this. So as I told you just now, when you reach the step until you get the z here, right? When you're able to convert the x, change until you get the z, you will normally draw out the normal curve. Okay, draw out the normal curve. Okay, then from there, you try to check the range needed to find in the questions. You have 2.5 negative and then 1.5 negative, right? You have these two. And you are asked to find the answer in between. In between means this part here. You want to find the answer in between. Okay, so remember just now we said the answer we have, we normally can see only the side end, right? So I actually believe that you can actually take the side end, right? The side end of 1.5, which is the bigger area, right? Minus out the side end of 2.5. Yeah, if you take the answer for 1.5, which is bigger area, minus 2.5, you should get the answer in between. Okay, so take the answer for 1.5 minus 2.5. Let's see what we have from the table values of 1.5 and 2.5 here. So 2.5 is this, 0.00621. Okay, then 1.5 is actually this, 0.0668. So we have these two values, this and this, to be written here. 0.0668 minus 0.00625, right? We have two answers here. Remember, 2.5 give me this, then 1.5 give me this, yeah? 1.5 is actually 0.0668. So we just put it back to the function here. Sorry, this is 621, huh? 621, sorry. Okay, then from there you find the answers, which is 0.0606. Okay. Just refer to your table and put down the values here. Then you can see the answers needed to be found and get the answers in between. Okay, this is for part A. Part A. Okay, now we go to the next one, part B. So estimate the number of days, just estimate only, right, roughly, to give me the answer for this during the year of 2020, where he takes this time to deliver the meals. Okay, just for information, in this year 2020, right, we have total days of 366 days, correct? 366 days, right? Okay, so as usual, just now we go back to the idea to find the probability like that, correct? We always go back to the basic definitions for probability. Probability we found in the part A is 06, and the total number of days, I do not know how many, but I know the grand total for the year itself has 366 days. I will just put it down here, 366. So I can actually find what is my NA here, right? So you can just move it up to multiply. Okay, and you round up to whole number, the number of days, right? So from here is 22 days. About 22 days, you have the people here, right? The postman here, send the mail within the time from 10 to 12 minutes. Okay, roughly 22 days. That's for part B. Okay, then we go to part C here. Given the probability that the postman takes more than K, okay, I say here, time taken for more than K to deliver the mails is 0.389. This is something given by the questions, yeah? I just write this in the form of maths notations, right? You can see that, oh, more than K minutes will be more than K, greater than K, and the probability is 0.0389. So from here, as we said, we always convert this to Z distributions, right? Convert to Z. So when you do conversions, you minus the mean, right? Just now the mean was what? The mean was 5.2, is it? I can't remember, sorry. Go back to the one. 15 and 2, sorry. So I have 15 and 2 here. And 2 here, right? Minus the mean over standard deviations, and this answer is 0.0389. Okay, so as usual, we draw the normal curve out. We draw the normal curve out. Okay, this value is for more than, right? More than means I will refer to the right-hand area. Right-hand area. Okay, so meaning I can actually get this answer directly from my table, yeah? This is 0.0389. I want to find what is the Z value here. I want to find what's the Z value here so that I can compare with this Z value. Okay, so let's take a look on the part here, on the graph again. So we need to find the answer with the probability of 0.0389. So this is the locations, 0.0389, right? I need to minus 3 from here. Because after I minus 3 from here, I will get this 0.0389, correct? So my location is actually here. Meaning, I will have the reading here as 1.763. Yeah, this part is not enough to reach the probability. I need to minus 3. So my answer for the Z should take 1.763. Yeah, my Z value will be 1.763. So we go back to the slide just now. This value I found is 1.763. So meaning K minus 15 per 2 is actually 1.763. Then I can find what's my K here. 1.763 multiply with the 2, then I plus with 15 to get the answer of K. So I just copy down my answer here is 18.526. Right, the value of K will be just 18.526. Okay. So I have last questions, just a fast one, right, before we end the sessions from my side. Okay, so the math for the reference book follows normal distributions with the mean of mu and standard deviation of sigma. Okay, so 16.8, they are having mass more than this. So one more time, I will just put down x more than 1.5 is 0.168, yeah? I convert this percent to decimals, okay? 5% less than this, 5%. So one more time, make sure you check the correct notations here. This is gram. I will put back as kg, 0.55, right? Okay, and this is 0.05. Okay, so I have these two notations with me. But as we said, we will change to Z distributions. 1.5 minus the mean. I do not know what is that. Standard deviation is also unknown, 0.168. Same thing go with this, Z, 0.55 minus the mean over standard deviations, 0.05. Okay, so as usual, when you reach until Z, you will see your normal curve, right? You will see your normal curve. Okay, this part, they want to find area more than with this. So I will try to find right-hand area because this one point to the right, right? I will have the right-hand area here as 0.168. Whereas for this part, I will have a normal curve. This case, I point to the left. I point this to the left. So I will have this as 0.05. The left-hand area is 0.05. I need to find what is the respective z value from my table to suit these inequalities here. Okay, so let's go to the table. 1.1685. I don't want the 5, I minus 5 here. That's why my reading will go to 0.962. So the first one is 0.962. Okay, and the second one, 0.05. Again, I don't want the 5 here. That's why I minus 5 from here. So the reading is 1.645 here, 1.645. Okay, so come back to this. This is 0.962. This is 1.645. Okay, but one thing, because this location is in the left-hand side, this location is in the left-hand side, this reading should have an F sign, yeah? Should have an F sign. So therefore, and now I can do a direct comparison. The reading for this had to be same with this. 1.5 minus mu over sigma is equals to 0.962. So I can write in a better form, 0.962 sigma, equation 1. Then the next one will have 0.55 minus mu over sigma as negative 1.645. So you have 0.55 minus mu equals to negative 1.645 sigma, equation 2. Okay, so you have these two equations to be solved. I believe that you can just solve like the simple simultaneous equations. For example, you take 1 minus the second equations, take 1 minus second, you have this as 0.95, the mu is being cancelled off. Then this part, you should have what? 2.607 sigma. And your sigma should be found easily. I just copy down my answer here, 3644. Yeah, just copy down this answer. Okay, solve your equation taking 1 minus 2. Then from there, you can find a sigma. And of course, after you get the sigma, sub the sigma here, right, into maybe your first equations and second equations, then you solve your mu. Yeah, you solve your mu. So your mu will be 1.1494. Okay, so for this case, you notice that in the questions of normal distributions, you must know what is the way you convert from x to z. You must understand how the way you read your table value and compare with the inequalities given here. Okay, so that is the part I want to share with you, right? Thank you so much. I think I will end my sessions here. Okay, thanks.
We will go for differentiation, yeah? So I will give some brief explanation about differentiation. Then we will go for 10 examples as well to show how to solve the question related to differentiation. Okay? So what is differentiation? So some of the book, textbook or whatever, we also known as derivative, right? So differentiation also known as derivative. So what is the notation involved using a differentiation will be this one, right? The notation, most of the students familiar with dy over dx lah. But sometimes, right, we can have y prime also, right? Y prime or f prime x. So these are the common notation for differentiation. Okay. So what is the meaning of differentiation? So we have two meanings of differentiation, right? The first one always refer to the gradient of the tangent. Right? It refers to the gradient of the tangent. That's why one of the application for differentiation will be finding the tangent line, right? Finding the equation of a tangent line. Okay. What about the second meaning of differentiation? Right? Second meaning of differentiation will be the rate of change. So that will be there another application for differentiation. Okay. So most of the time when we find dy over dx or dy over dt or y prime or f prime always means these meanings, the gradient or tangent or the rate of change. Okay. So in order to apply the application, first we must know how to find the dy dx, right? You must able to differentiate the function first. So how to differentiate function? We use the rules, right? So next, I will show you the general rules about differentiation. Okay, I won't go in detail because you have learned it. Now later, we are going to apply it. Okay, use it. So the rules of differentiation, the first one, of course, will involve the constant, right? Y equal to A. No x, huh? Just a number. Y equal to a number, constant. So when we differentiate it, you will get 0. Okay? Because no variable x there. Right? So it's a constant function. Right? What about if it constant together with the power function? This is the formula you are using, right? Power function. X power n. Right? We call it power function. So you want to differentiate, you have to differentiate the variable x with respect to x. Okay? So the constant, we keep it, right? We will keep the constant. So when you find dy over dx, we will keep the constant. We only differentiate the power function. So according to the formula, we bring down the power n, then the power less 1. Okay? So when you multiply the a, we have this. Okay? Some of the textbook, right? Some of the textbook will put the n in front. It's the same. Right? You can have a n x power n minus 1, or it's also same as n a x power n minus 1 because it's a multiplication. Fulfill the commutative rules. So both acceptable. Okay. So this is the second important rules for differentiation. Okay. Then the next one is, what about we have addition and subtraction between two functions? Example, like this, right? A function plus another function, or a function plus a function minus another function, right? Addition and subtraction of two different functions. So how to find the dy over dx now? So how to differentiate the function y now? With respect to the variable x, right? With respect to the variable x. So these are the rules, right? For addition and subtraction, we just what? Differentiate function by function, right? We differentiate function by function. So we have the result, okay? Simply just differentiate the function of the x, differentiate the function of the u with respect to x, then plus differentiate the function v with respect to x. Similarly, for subtraction of two functions, right? Differentiate the function u with respect to x, then minus differentiate the function v with respect to x. Okay? So this is for addition and subtraction. What about multiplication and division? So for multiplication, can we also say that, can I say that the dy over dx also same as differentiate the function u with respect to x, then multiply, differentiate the function v with respect to x? Can or cannot? The answer is cannot. This one is wrong. Right? So this one also, can we differentiate the function y with respect to x, same as differentiate the u with respect to x, then divided by differentiate the v with respect to x? Can we do this? The answer is cannot. Okay? So for multiplication of two functions and the division of two functions, we cannot just differentiate like that. Okay? So what we are going to do is we come out a rule. Right? You have learned the rules. The rules we call product rule and quotient rule. Okay? So the answer should be, the correct formula that you should be used will be product rule. Right? This is a correct formula, not the just now one. Okay? So this is called the product rule. Right? Product rule. Why product? Multiplication. That's why we call products. Okay? What about the next one? Division. Then this will be what we call the quotient rule. Okay? This is called the quotient rule. So we also know that sometimes you have composite function, a function inside another function, right? Composite function. So to use the to differentiate a composite function, we use the chain rule, right? So this is the last rule that you learn in SPM. We use the chain rule. Okay. So these are the basic rules, right? In order to find the dy over dx, differentiation. Okay. Later in our example, right? The example question, we are going to apply all these rules, right? To find dy over dx or the derivative. Okay. So next one will be previously all the y prime, f prime, dy over dx is what we call the first derivative. Means we differentiate for the first time. We call first derivative. Then what is second derivative? Or sometimes we can go for higher, right? Higher derivative. But in SPM, we will learn until second derivative, right? Not more further. You want to learn higher derivative, learn higher level, right? So what is second derivative? It means we are going to differentiate the first derivative again, right? We will differentiate the first derivative again. So the notation now will be, this will be the notation now, right? D square y over dx squared. And then the y prime become y double prime. F prime become f double prime. So this is called the second derivative. Why we need second derivative? Because we need it for the application, right? We are going to use it for the application. Okay. So how many applications you have learned so far in SPM? These are the application of differentiation you have learned so far in SPM, right? So do you aware that the first two applications, right? First application and the second application is actually from the meaning of differentiation there, right? dy dx represent the gradient of tangent. So that's why we should able to find the equation of the tangent line. What about the normal? We know that the normal is perpendicular with the tangent, right? So if this is a tangent line, so the normal line will be perpendicular with the tangent line. So this is normal line. So if I have the gradient of the tangent line, if let's say the gradient of the tangent line is m1, right? M2 is the gradient of normal, right? Gradient of normal line. So what is the relationship between them? So we know that the relationship between them is m1 multiply m2 to equal to -1. All right. So this is a relationship between the normal line and the tangent line. Okay. But of course they will intersect at a point right? So you are going to intersect at a point. Okay. So you can call point P or point Q or whatever, right? They will intersect at a point. Okay. So we are going to use the relationship here to solve any question involve the first application, right? Find the equation of tangent and the normal to a curve. Okay. Then we know that the second meaning of differentiation is the rate of change. So that's why we are going to involve the rate of change problem as well, right? The third and the fourth application here, right? They will involve second derivative now, because we can use a second derivative to justify or to verify whether the turning point is a maximum point or a minimum point. Okay. So when a problem involves maximum point, that is involve optimization problem, right? So your optimization problem can be something is maximum or something is minimum, right? So that's why the third and the fourth application, they are related, right? They are related and they are using second derivative to check the maximum point or the minimum point. Okay. And then of course the last one, we are going to learn the small changes and the approximation of differentiation. Okay, so these are the notes about differentiation, free summary of the differentiation. So how to apply all these, we will go for the 10 example I will show you. Okay, so let's go for the example, right? So we will go for paper 1 and paper 2 lah, right? The question are similar to the paper 1 question and the paper 2 question of additional mathematics in STM. Okay, so let's go for example 1, right? So first of all, you must read the question carefully and try to find the answer as precise as possible. Okay, so now we look at the question. Given the function y in terms of t, right? So we have function y in terms of t, 4 minus 2t squared. Also given dx over dt is equal to 2 over t. So I have 2 info here. So you are going to use these 2 info to solve the question. So what is a part A? So I would like to find dy over dt. dy over dt means differentiate the function y in terms of t. So your function y is already a function in terms of t. So I just differentiate it, right? So first term is 4, a constant. Differentiate a constant, you should get 0, right? So suppose you get 0. Then what about second term? Second term is negative 2t squared. So differentiate it, we keep the constant. We only differentiate the variable. What is the variable? According to dy over dt, so your t is the variable. So differentiate the t power 2. So according to the formula, we bring down the power, then the power less 1. So 2 minus 1, of course 1. So most of the time, t power 1, we just put t lah. Right? The power 1, no need lah. Right? No need to put the 1 there. Okay? So simplify it, we have negative 4t. Okay? So this is the answer for part A. Negative 4t. What about part B? Part B, I need to find dy over dx, right? First one is dy over dt, but the next one is dy over dx. Now we have a problem is, the function y is not in terms of x, right? It's in terms of t. So how to find dy over dx here? So we have to use a change rule already, right? So according to the change rule, we know that dy over dx is equal to dy over dt times dt over dx, right? So according to the change rule, we know that dy over dx is equal to dy over dt times dt over dx. So what is dt over dx? Right? dy over dt, we got it from part A result, right? Part A result. So we have negative 4t here. But what about dx over dt over dx? So we got second info here, right? Remember, we have second info. So dx over dt is 2 over t, right? What about dt over dx? Right? It's like turn upside down, right? So that's why dt over dx is t over 2. Okay? So substitute this side inside here. So we have t over 2. Simplify it. Be careful the negative sign. The 2 and the 4 we cancel. We got negative 2t squared. So is this your final answer? Is this your final answer? The answer is no. Why? Because you read the question, I want the answer in terms of y. Right? I want the answer in terms of y. It means your answer must be got variable y. But unfortunately, your answer is in terms of t. Right? So I need to convert into y. From where? From the relationship between t and y. Right? So do you see this is a relationship between t and y? Right? So from here, what is your negative 2t squared? Right? So from here, we know that the negative 2t squared will equal to y minus 4, right? So substitute inside here. So final answer will be y minus 4. Okay? So that will be the solution for question 1 in paper 1. Okay? So if you have any question, you can ask in the chat, right? In our Q&A part, right? We will answer you accordingly. Okay? If not, then we go for next question. Next question will be question 2. A diagram is given, right? We call it diagram 1. So diagram 1 show a parts of curve y equal to 2x plus 15 over x plus 3. And a straight line y equal to 3qx, right? So what is the info given? So you must read the info, right? A curve and a straight line. Then next info will be given that the straight line is parallel with the tangent of the curve at point P, right? So I would like to find the value of Q. So how to find? So what is called parallel? Right? Two lines are parallel means their gradient will be same, right? So if this is line 1, this is line 2, if they are parallel, right? So the gradient of line 1, so maybe I will write here will be y equal to m1 x plus c1, m2 x plus c2, right? So the gradient, when you say parallel, right? When you say parallel means they have same gradient. Okay? So L1 parallel with L2, then it means the gradient 1 is equal to gradient 2, right? The slope of the line will be same. So it means the slope of the line for this straight line will be same as the tangent line. So if you have tangent line here, so sketching, so if this is a tangent line at point P, right, tangent line at point P, it means these two gradients will be the same. Okay, so what is the gradient of tangent? Gradient of tangent means dy over dx, right? Dy over dx. So you need to find the gradient of the tangent at P, right? Gradient of tangent at P. Okay. So the gradient of tangent at P, we need to involve the curve because your point P is lines on the curve, right? So I need to find dy over dx, the gradient at point P. So we have a function divided by another function, right? It seems like u over v, right? Right? It's similar with u over v, right? So that's why I'm going to apply quotient rule. So according to quotient rule, we are going to have v du over dx minus u dv over dx over v squared. So this is the quotient rule, right? So I'm going to apply the quotient rule. So what is your u? So your u is 2x plus 15. What is the v? We have x plus 3. So that's why du over dx will be differentiate with respect to x. We have 2 here, right? And similarly, differentiate the function v with respect to x. We have 1. So substitute into the quotient rule formula. So that's why we have dy over dx. We have v x plus 3 du over dx will be 2 minus u 2x plus 15 and dv over dx is 1 divided by v squared. So x plus 3 whole thing squared. Okay, simplify the answer. I believe that you are going to have negative 9. Okay, I simplified. Sorry, yeah. Get used to. Okay, so expand the top. So we have 2x plus 6 minus, be careful the negative sign, yeah? So minus times 1 only lah, huh? 2x plus 15 times 1, we get back 2x plus 15. So we have 2x, not plus, huh? Because negative plus become negative now. So be careful the negative sign, okay? Okay, so divided by x plus 3 whole thing squared. Okay, so it means simplify the top, 2x minus 2x out, 6 minus 15, we have negative 9 over x plus 3 whole thing squared. Okay, so this is your dy dx. So I want to find the value of dy dx at point P, right? So at point P. Now the thing is, I need to know what is your point P, right or not? So you must know the coordinates of point P. What is the coordinates of point P? So we know that the P lies on the curve, right? So the P lies on the curve and is lie on the y-axis, right? So lies on the y-axis means the coordinate of P, the x must be 0, right? Because it's lie on the y-axis. So x must be equal to 0. So how to find the y? So substitute 0 here, right? So let x equal to 0 here, right? Then you can find the y value or the y coordinates of point P. So when x equal to 0, you will get that y is equal to 15 over 3, right? So the answer will be 5 lah. So the coordinates of point P will be 0, 5, right? 0, 5. So, but when we want to find the dy dx at point P, right? What is the value for dy dx at point P? So we are going to substitute the x value involved lah. So that's why we have negative 9 over 3 squared because x is equal to 0 mah. So we have negative 9 over 9, we have negative 1, right? So this is the gradient of the tangent at point P. Then it's parallel, right? The line is parallel with the tangent at point P, right? When it parallel means what? It means, so therefore, you can find the Q now, right? So hence, the Q will be, the gradient of the straight line will be 3Q, right? The gradient of the line, right? If you compare with the mx plus c, right? If you compare, you can see the gradient will be 3Q and the c, of course, is 0, right? If you compare, right? If you compare. So the gradient, since they are parallel, so the two gradient will be the same. So 3Q will equal to negative 1 and then Q will equal to negative 1 over 3. So this is the answer for question 2. Okay? Any questions so far? Right? You can type your answer in the chat room. If you type your question in the chat room if you have any questions. Okay? Okay? So next, we go for next application for paper 1 of additional mathematics involve differentiation. So next one will be this. Very straightforward question. I just want to find the first derivative of the function y in terms of x. Okay? So we know that this one, you got two ways to do it. Either you expand everything and then differentiate term by term. If you don't want, you can use product rule. Why product rule? Because I can have y equal to function u times function v, right? So I can separate this is function u, then multiply function v. Okay. So I'm going to use product rule now. Okay. So let u 4x squared. Then function v 5 minus 2x whole thing squared. Whole thing power 3. Okay, cube. So I would like to find du over dx. Alright, because according to the product rule, dy over dx is equal to u dv over dx plus v du over dx. Alright, so this is the product rule. So I have u, I have v. Now I need to find dv over dx and du over dx. So differentiate the function u with respect to x. So we are going to have, keep the constant, differentiate x squared, we have 2x. So that's why we have 8x. Okay. What about dv over dx? dv over dx, you can use the formula, right? So if you look at the v, 5 minus 2x power 3. So this is a function inside the power 3 function, right? So if you can differentiate directly, you can go ahead. If you cannot, we use what? Change rule, right? We can use a change rule. Okay? So according to the change rule, you are going to let the, you can let the, what you call w equal to 5 minus 2x. Right? So the v become w power 3. Right? So if you differentiate with respect to w, you have 3w squared. Right? If you differentiate the w with x, you have negative 2. Right? So by using the change rule, so we know that the dv over dx will equal to dv over dw multiply dw over dx. Right? So dv over dw is 3w squared. Multiply with negative 2. Right? So we have negative 6w squared. But I don't want in w. I want in x. So what is your w? So according to w is here. Right? So it will equal to negative 6 5 minus 2x. Then whole thing squared. Right? So by using a change rule, we find dv over dx. So we have negative 6 5 minus 2x whole thing squared. Okay? This is just to find dv over dx. But the question want to find dy over dx. So we are going to use a product rule to find dy over dx now. Okay? So now, by using the product rule, dy over dx will equal to u 4x squared times the dv over dx. We have negative 6 5 minus 2x whole thing squared. Then plus v. This is your v. And what about the du over dx? du over dx is 8x. Okay? So you complete the differentiation. Now what you have to do is simplify answer. So simplify answer, we have negative 24x squared and 5 minus 2x whole thing squared plus 8x. Okay, so look like they have common factor. So what you are going to do is you are going to factorize the common factor, right? So check the common factor. What do you have for the first term and the last term? Right? Common factor. Right? So we know that for the first term here, And the second term here, they got common factor 8. 8 and 8, right? We also have x power 1 and x squared. So common factor x, we can factorize. And we also have 5 minus 2x. This is power 2. This is power 3. We factorize the smallest power. So it means both terms consist of 8, consist of x, consist of this one. Right? So we factorize them. Okay? So first term, when you factorize 8x 5 minus 2x holding square, so negative 24, factorize the 8, we remain negative 3. X squared, factorize the x, we remain x, right? 5 minus 2x holding square, factorize, no more, it's 1, right? So that's why no more. Then we go for second term. Second term, right? Plus, now we go for second term. 8x, factorize already, no more. 5 minus 2x power 3, factorize power 2, we remain power 1. Right? We remain power 1. Of course, power 1, you no need to write the power 1 as well. Right? Just put 5 minus 2x will be okay already. Right? Okay? Then simplify the bracket. Right? You simplify the bracket. We are going to have something in this one. Okay? So we have negative 3x. Right? Negative 3x plus 5 minus 2x. Okay? So simplify it. We have 5 minus 5x. So do you realize that 5 minus 5x also got common factor? 5, 5. So we factorize the 5, multiply with 8. That's why we have 40. Okay? So factorize the 5, we have 1. Factorize the 5x, we have 1x. So that's why this is your final answer for question 3 of paper 1. Okay? Factorization process. Okay? Okay. If okay, then we go for next question. Question 4. So question 4 is quite a long question. What you have to do is you try to understand the question one by one. We are going to satisfy the condition. Okay? So read the question. We have a diagram. We call it diagram 2. Show a curve y equal to fx. So we have a curve y equal to fx. So this is a curve y equal to fx. Then we have a straight line y equal to gx, right? Straight line. Then we have 4 points, right? Point A, B, C lie on the curve, right? So you can see point A here, point B here, point C here, right? They are lines on the curve y equal to fx. And then the point D lies on the straight line. So point D is right here, line on the straight line. Tangent to the curve at point B and C are parallel to the x-axis. So it means, right? It means these two tangent lines at point B, tangent line, and the tangent line and point C, right? Their tangent line is actually parallel with the x-axis. So it means they are horizontal lines, right? 3 are horizontal lines. Okay? So now state which point that satisfies the following condition. So what you have to do is you just state A, B, C, D, which point, right? Fulfill the condition. Okay, we look at the first one. dy over dx is more than 0. What does it mean? dy over dx more than 0 means the gradient of the line is positive. Right? Is positive. Normally means it will look like this lah, positive line. Right? positive tangent line. Okay, so which point fulfill? Now you look at point A. Point A, if you have tangent line, the tangent line look like this, right? It's a negative slope. So point A cannot lah. Point B, the tangent line is a horizontal line. Also cannot lah. What about point C? The tangent line is a horizontal line. So cannot also. Only point what? Point D. Because what? Tangent line at the point D same as the straight line lah. So do you see it's a positive? So that's why the answer for part A will be point D. Right? So the answer for part A will be point D. Okay? It's a positive slope line. Now we go for part B. dy dx equal to 0 means what? The gradient of tangent is 0. 0 means what? Is a horizontal line. Right? Gradient of tangent is 0 means is a horizontal line. So now you check the 3 points. Point A is not a horizontal line, right? So the answer is not point A. Then do you look at point B and point C? Is their tangent line horizontal? Yes, right? So that's why the answer for part B will be point B and C. Right? So this is the answer for part B. Okay? Now we look at the third part C. Second derivative less than 0. What does it mean, second derivative less than 0? If you read, right? If you read this one, the second derivative less than 0 actually means we have the turning point. Right? Is or are maximum or minimum? It will be the maximum. So we have maximum turning point. Okay? So how many turning points we have here? We only have 2 turning points, right? B and C. So only 2 turning points. So which one is considered maximum turning point? So it will be point, yep, point C. So that's why the final answer for part C is point C. Okay? So this is the answer for ABC of question 4, right? So you must understand what is the condition given. What is the condition represent, right? So from the condition, then we match the given points to find out the answer. Okay? Any question? So if not, then we go for the paper 2, right? Paper 1, they are quite straightforward lah, right? Then we go for paper 2. Paper 2, you need for more application. Okay? So look at question 5 until question 10 for paper 2. Okay? So question 5. Read the question and try to find out what the question wants. Okay? So given a curve. So we have a curve. Y equal to 12 plus 6x minus x cubed. And we know that this curve passes through this point P. Right? So what you want to find, part A? I would like to find the equation of normal, right, at point P. Right? Equation of normal of the curve at point P. So I want normal, not tangent. You have to be careful. Okay? So for part A, what you have to do is you need the gradient because I have the point already, right? I have point P. So what I need to find the equation of a line, I have a point. I need another info, the gradient. So I need to find the gradient of normal. Then together with the point, we can find the equation. Okay? So what is the relationship between the gradient of normal and the gradient of tangent? Right? I just showed you just now, right? The relationship between them will be gradient of tangent multiply gradient of normal is equal to -1. So we use this info to find the gradient of normal. Okay? So first, find the gradient of tangent. So gradient of tangent, dy over dx. So find the dy over dx. this is the curve. Since the normal line is at a point on the curve, so we are going to find dy dx of this curve. So dy over dx, we integrate here, got three terms. We differentiate term by term, right? Differentiate term by term. Differentiate the first term is a constant, we get 0 lah. Then differentiate the second term, 6x, we have 6. Differentiate the third term, x power 3. So we have bring down the power less 1. So we have negative 3x squared, right? So at point P, right? So the gradient of the tangent. So this is the gradient of the tangent. Right, at P, so equal to, substitute the x because I need to have the x value. So 6 minus 3, be careful the negative sign. So we have 6 minus 3 times 4. So the final answer, 6 minus 12, negative 6. So this is a gradient of tangent, but the question, I need the normal line. So I need to find the gradient of normal. Right, at point P. So what is the gradient and normal? So I use m can. So the m will equal to negative 1 divided by the gradient of tangent. So negative 6. So final answer is 1 over 6. Okay. So once you have the gradient, then you have a point, we can find the equation of the normal line. So the equation of the normal, right, at P will be using the formula, right? Y minus a point, right? The point P. So y minus the coordinates, the y coordinates 8, and then equal to the gradient 1 over 6 multiply x minus the x coordinate. So x minus x, x negative become plus lah. So become x plus 2. Okay. So simplify it. Alright. So 1 over 6 plus 2, multiply 2, we have 1 over 3 lah. Then the plus 8 bring to the other side, we have a minus 8 bring to the other side, we have plus 8. Okay. So y will equal to 1 over 6x plus, this one will be 25 over 3. Okay. So this is the equation of the normal for the curve at point P. Okay. So this is the answer for part A. Okay. Now what about part B? Right? What about part B? Given that the tangent of the curve at point Q is parallel, right, with the tangent at point P. So parallel means they have same gradient, right? So parallel means we have same gradient. So it means the gradient at point Q same as the gradient at point P, right? So what should we do? So sorry, let me put some space for the part B. So the gradient at point P same as the gradient at point Q, right? Same as the gradient at point Q. So what we are going to do with that? So what is the gradient at point P? The gradient at point P is here, right? The gradient at point P is here. So the gradient at point Q must be same as negative 6. So what is the gradient? Right? Tangent. So gradient of tangent is this. Right? So that's why for part B, we know that 6 minus 3x squared will equal to negative 6. Right? Gradient at point Q. This is a gradient at point Q. Right? Gradient of tangent line at point Q will same as the gradient of the tangent at point P. So point P is negative 6. point Q, not sure yet, but it will come from 6 minus 3x squared, right? So that's why we form this equation, okay? So solve this equation. What do we have? So 3x squared will equal to 6 plus 6, 12 lah. So x squared will equal to 4. So x is equal to plus minus 2. So the x value plus minus 2. Which one is point coordinates or point Q? Plus or minus? Plus 2 or minus 2? Look at here. The P is minus 2. So if you let the x is negative 2, then you will get back the point P, right? So it means minus 2 is belong to P. So the Q will be plus 2, positive 2. Okay? Select the positive 2 because the negative 2 belongs to point P already. Okay? Then what about the y coordinates? How to find the y coordinates? So since point Q is lies on the curve also, right? Point Q is lies on the curve. So I can find the y coordinate by using the curve equation, right? The equation of the curve. So the y coordinates of the Q right, will be substitute the 2 into the formula. So 12 plus 6x, the x is 2, then minus 2 power 3, right? So that's why the final answer will be 12 plus 12 minus 8 lah. So you can get the answer 16 here, right? So that's why point Q will be so point Q is 2, 60. So this is the coordinates of point Q. Okay. So this is a question 5 for paper 2. Okay. So far we only involve the first application, right? The equation of tangent and the equation of normal. And then we also involve how to find the dy dx by using product rule, quotient rule, or change rule, right? So we didn't go for a further application, right? So that's why question 6, question 7, until question 10, we will more on the application. Okay. So this is the first application. Find the equation of tangent and equation of normal, and also the gradient of tangent, gradient of normal, right? Then the next one, we will go for another application. So a diagram is given again. It shows a front view of a window, right? Front view of a window. So the info given, right? Always check the info given, right? The arc of the window is semicircle. So the arc of the window, this is semicircle, right? And the perimeter of the whole window is 8 meters, right? So we have these two info. So when you want to answer the question, always go to the info, the given info, okay? So part A, what you want to find? Part A, show that the surface area of the window is A equal to 16x minus 8x squared minus 2 pi x squared, right? So surface area basically means the area, right? So area of this window. So you can see the window is a combination of a rectangle and also a semicircle, right? So what is the area of rectangle? So we have the height here is 1 meter, and then the length will be 4x meter. So that's why the area of the rectangle, right, will be 4x times 1, right? So I want to find the surface area. So A is equal to area of the rectangle 4xy, right? And I need to plus the area of the semicircle here. So semicircle, we know that the area of circle, right? Circle area will be pi r squared, right? area of the circle, pi r squared. So I need to know the radius. So you look at here, what is the radius? So this one will be the diameter, right? Will be the diameter. So what is the radius? So half radius. So total is 4x, right? So the radius will be 2x, right? So we know that the radius will be 2x. Right? And since this is a semi-circle, so we have to the total area of the circle divided by 2. So we have pi r squared divided by 2. So we have pi r squared divided by 2. Right? So what is your r? So just now we mentioned that from here the r is 2x. So it's 2x. So simplify it. For 2x squared, we have 4x squared. 4x squared divided by 2, we have 2 pi x squared. Right? Okay. The answer here, I need to have these. Right? Look like not same, right? Not. So how to get these answer? So if you compare, you can see there is no y here, right? No y variable here. So it means I need to change the y here into x, right? So how to do it? Always go back to the info of the question. So just now, semicircle apply already. So we have another info here, right? So this info, right, you're able to let you to find the y. Okay? So what is the perimeter of the window? So if you look at the window here, what is the perimeter? Right? So the perimeter will be 2y, right? The side here and the side here, 2y. And then one side here is 4x. So 2y plus 4x. And plus, I need to know the length of the arc, right? The length of the arc here. So what is the length of the arc? It's a half, it's a semicircle. So half of the perimeter of circle. So perimeter of circle is 2 pi r. So half of it, pi r. Right? What is your r? R is 2x, so it should be 2x here. Right? Pi r. So the r is 2x, so that's why you have 2 pi x. Okay? And what is the given perimeter? Is 8. So we know that 8 is equal to 2y plus 4x plus 2 pi x. So I need to find the y. But all terms, right, consist of 2, 2, 2, 2, common factor 2. So you can simplify it first if you want to. Right? So from here, I have the y in terms of x. So the y will be 4 minus 2x minus pi x. Right? So substitute this one into the question here. Right? Because I don't want the answer in terms of y, I want the answer in terms of x. So y will be 4 minus 2x minus pi x here. And plus 2 pi x. So simplified it, expand it, and simplified it. We have 16x minus 8x squared minus 4 pi x squared plus 2 pi x squared. So 4 negative 4 pi x squared plus 2 pi x squared. So that's why you have the given result. Okay, so this is the answer for part A. You show the surface area of the window is the given one. Okay, and what about part B? Part B. Find the height of the window, right? The height of the window when the surface area is maximum. So this is what we call optimization problem, right? I know that the surface area is maximum. I want to find what is the height. Okay. So surface area is maximum. So you have to make sure the surface area is maximum. How to make sure? You have to make sure that the dy over dx is equal to 0. Right? Actually, it's dA over dx is equal to 0. And then in order to get maximum, the second derivative must be less than 0. Right? Must be have a negative value, less than 0. Okay? So we are going to use the result part A to find the answer. Okay? So now we go for part B. So you have the answer for part A already, right? It's given. So even you cannot prove the part A, you can use it for part B. Right? Even you cannot answer the part A, but you can use the answer of part A to find the part B. Okay? So what is a given surface area function in terms of x, right? So the given surface function is a equal to 16x minus 8x squared minus 2 pi x squared, right? So the result for part B. So I need to find the maximum. Maximum means I need to differentiate it with respect to the variable. So you only have variable x here. So you only differentiate with respect to x. So differentiate it, we have 16 minus, differentiate the second term, we have 16x. Differentiate the third one, we have negative 4 pi x, right? So of course, you can substitute the pi 3.142, right? You can substitute right here or you can substitute after that, it's okay. So the maximum point always comes from the turning point, right? The turning point. So how to get the turning point? Let the first derivative equal to 0, right? Let the first derivative of the surface area equal to 0 because surface area is maximum. So you need to differentiate the surface area. Okay. So let it equal to 0. So if you solve it here, since they have 4, 4, 4, 4, 4, we can simplify the function also. So 3.142 x equal to 0. So you will realize that 7.142 x is equal to 4. So x is equal to 4 divided by 7.142. You are going to get 0.56. Okay. So this is the x. Will it make the surface area maximum? So we check with second derivative. Right? We check with the second derivative. So differentiate again for the function. So this is your first derivative. So differentiate it again for the second derivative. First term is constant. So differentiate constant, 0. So we differentiate the second term, we got negative 16. Then differentiate the negative 4 pi x, we got negative 4 pi. So basically a negative number minus a number, so we got negative answer, right? So this means what? This means x equal to 0.56 will maximize the surface area. Right? So it fulfill our question, right? Yes, I want the surface area. Sorry, I want the surface area is maximum. So it fulfill our question, right? Right, surface area is maximum. So we know that this point will maximize the surface area, right? Fulfill. So this is the answer that we want. Okay. So what we want, the height. So we want to find the height of the window. So look at the diagram. Look at the diagram here. So where is the height of the window? Right? So if you look at the diagram, what is the height of the window? Right? So we can see that the height of the window is here, right? This is the height of the window. So basically is the y plus the radius r, right? So the height of the window is actually y plus r, right? So that's why we find the height, right? The given will be y plus r, right? So what is y? According to here, this is a y, right? The y is here. So the y is 4 minus 2x minus pi r. What is r? Just now the radius. What is the radius? Is 2x, right? So plus 2x. So do you realize a negative 2x plus 2x out? We have 4 minus pi r, right? So I know 4 minus pi x, sorry. So this is not r, this is x, huh? X and x. So what is your x? The x value is here, right? We'll maximize the surface area. So 4 minus the pi is 3.142. So the x is 0.56. So simplify the answer. You have 2.24. Right? And of course, what is the height in meter? So this is 4.24 meters. Okay? So this is the answer for question 6 of this paper. Okay? Okay, next we go for another application. This question 6 is about optimization problem. Right? The application optimization problem. We try to maximize the surface area, then to find the height of the window. Right? Next, we go for the small changes. Right? The small changes. So question 7, read the question carefully, and we are going to find first. Find the dy over dx when x is equal to 1. Right? Find the dy over dx when x equal to 1. So, what is the function y? We have x squared minus 4 over x. If you can change to the power function, will be much better because we have the formula for power function. So 1 over x, we know that 1 over x basically means x power negative 1, right? So we can change to 4x power negative. Okay? So find the dy over dx. So we have two terms. Differentiate first term, x squared, we have 2x. Differentiate second term, keep the constant. Then we differentiate this one, bring the power, we have negative 1. Then the power, less 1. Negative 1 minus 1, we have minus 2. Right? So if you simplify it, you are going to get negative become positive now. So be careful the sign. So x power negative 2, we know that is over x squared. So we can change to this one. Right? So what happened when x equal to 1? What is the value of dy over dx? So when x equal to 1, the value of the dy over dx will equal to 2 times 1 plus 4 divided by 1. So final answer will be 6. Right? 2 plus 4, 6. Okay? So this is the result for part A. Okay? Now what about part B? I would like to find approximate change in x when the y changes from 2 to 1.96. From 2 to 1.94, right? From 2 to 1.94 means decreasing. So the small change in y will be a negative number, right? So what is the formula given? So when you learn the small change or approximate change, this is the formula, right? Delta y approximately equal to the dy over dx multiply delta x, right? So this is a formula. Involve the approximate change, right? So from the question, we know that the delta y, right? We know the delta y because what? Y changes, right? Changes from 2 to 1.94. So you are going to have 1.94. You will find the small change, minus 2. So from here, you have negative 0.06. Right? Then I also need to find the dy dx when x equal to 2. Right? When x equal to 2, right? Original value, right? Original value of the dy over dx. So when x equal to 2, what is the value of dy dx? So dy dx will be 2 times 2, right? So dy dx is right here. So when x equal to 2, right? When x equal to 2, you have 2 times 2 plus 4 divided by 2 squared. So from here, 4 plus 1, we have 5. Okay? So hence, substitute into the formula here, I can find the change in x. So the delta y is negative 0.06, approximately equal to dy over dx at the origin point 2. So we have 5. Then multiply the delta x. The question would like to find the delta x, right? Small change or approximate change in x. So delta x. So from here, of course, we know that the delta x will equal to negative 0.06 divided by 5. So that's why we have negative 0.012. Okay, so this is the answer for part B, right? Part B result. Okay, so this is the 5th application of differentiation, right? Approximate change. Okay, next one, we go for another application involved in the turning point, maximum turning point or minimum turning point, right? So we need to find, of course, first the turning point first, right? Then after that, we need to determine each turning point is a maximum or a minimum. Okay? So what is turning point? How to find turning point? You want to find the turning point, you must let the first derivative is equal to 0, right? So you need to find dy over dx again, right? So y, right? We look at part A. So this is the curve given. So if you expand it, you will realize that you have x power 3 plus 3x squared minus 1 over 2. So we have 1, 2, 3, 3 terms, right? So first, you want to find the turning point, you must have the first derivative. So differentiate the function y with respect to x. So differentiate the first term, x power 3, we have 3x squared. Differentiate second term, we have plus 6x. Then the third term is a constant, negative 1 or 2, no variable x there. So differentiate constant, we should get 0. Okay? So to find turning point, you have to let the first derivative equal to 0. Right? This is to find turning point. Right? To find the turning point. Right? Always let the first derivative equal to 0. So my first derivative is 3x squared plus 6x is equal to 0, right? So simplify it. We have this one. Okay? So factorize it. Remember, factorize it are not divided by x. You want to find the value of x. So you cannot divide it by x both sides. You divide it by x both sides, you actually cancel one of the possible solution already. Right? Remember, never divided by a random variable if you want to find the value of that random variable. Okay? So factorize the x. That's why we have 2 points. Right? So it means we are going to have 2 turning points because you have 2 x value here, right? So how to find the coordinates? So this is the x coordinate. X equal to 0 will be the x coordinate of the first turning point. X equal to negative 2 will be the x coordinates of the second turning point. So now find their corresponding y value, right? So y value, of course, must get it from the curve, right? y value. Do you see y here? So that is a y value that we are going to find. So at the first point, when x equal to 0, the y is equal to negative 1 over 2. Right? Then second point, when x equal to negative 2, then what is the corresponding y value? You also can use this formula because same. Right? Same. Because you get it from here. So it will equal to negative 2 whole thing power 3 plus, so be careful the negative sign again. Right? So the answer will be negative 8 plus 12. Right? 3 times 4, 12 minus 1 over 2. Negative 2 whole thing square become positive 4. So that's why 3 times 4, positive 4. So final answer, you will have this one 7 over 2. Alright, so the turning points are so first point 0, negative 1 over 2. And second point negative 2, 7 over 2. Right? X coordinates and Y coordinates. So this is the answer for part A. Next, we have two turning points, right? Are they maximum point or minimum point? We are not so sure, right? We are not so sure. So what should we do? We are going to use a second derivative test to test it. Okay? So since I said second derivative test, right? So it means, right, you have to differentiate again. Oh, sorry, I did the dy over dx by dy. I can write again. Okay? So now we go for part B. So I need to determine the turning point is maximum or minimum. I need to differentiate again, right? So from part A, you know that your dy over dx is 3x squared plus 6x, right? So I need to differentiate it again to confirm is a maximum turning point or is a minimum turning point, right? So 2 points, right? So differentiate again. According to second derivative, we need to differentiate again. So differentiate again to get the second derivative. So first term, 3x squared. Differentiate it, we have 6x. Second term, 6x, positive 6x. Differentiate it, we have 6. Right? So since we have 2 points, right, 2 points, so we will check point by point. So first point, I need the x value because the second derivative is 6x plus 6. I need the x coordinates. So first point, what is the x coordinates? 0. Right? First turning point, x equal to 0. So the second derivative value will equal to 6, right? Times 0 plus 6. So of course you get 6. So this is positive or negative? Positive, right? More than 0. 6 definitely more than 0. Means what? It means this point is a minimum point. Right? It means the first turning point is a minimum point. Okay? Now we check the second turning point. The second turning point, the x value is negative 2. Right? The x value is negative 2. So what is the second derivative now? So we have negative 2 plus 6. So negative 12 plus 6, we have negative 6. So negative 6 is a negative answer, right? Negative number. So at the second turning point, second derivative value is a negative number. So the conclusion will be second turning point is a maximum point now. Okay, according to the second derivative test. Okay, so this is the result for part B. two turning points, then use a second derivative to determine is a maximum point or is a minimum point. Okay. If okay, now let's look at another application. So far, we have looked at the equation of tangent, equation of normal, turning point, maximum or minimum, optimization problem, small changes. We still have one more, right? The rate of change problem. So far, we haven't touched the rate of change problem yet. So that's why question number 9 will involve the rate of change problem now. Okay? So the rate of change means you are going to differentiate with respect to t, time, right? Involve time. So the denominator of the first derivative always will be over dt, right? Divided by dt, divided by dt. Okay? So read the question, what the question wants. Given a cuboid, right? With a square base. So with the side of x cm, and the height of the cuboid is 3 times of the side, right? So if possible, you try to draw the diagram, right? You try to draw the diagram. So we know it's a cuboid. The base is a square, right? The height is 3 times of the side. So the cuboid will be roughly look like this. Right? This is a cuboid. So we know that the base right? The base is a square. So the top will be same as the base. The top will be same as the base. So the side will be x cm, right? X cm. What about the height? Given the height will be 3 times of the x. So this will be 3x, right? So this is the cuboid for question number 9, right? The diagram of the cuboid of question number 9. So now we look at part A, what the question wants. So given that the side of the cuboid x is increasing, so keyword increasing, right? At a rate of 0.2 centimeter per second. Then your question, you would like to find the change of the volume, the rate of change of the volume when the volume is 192 centimeter cube. Okay? So given what? Part A, given the rate of change of the x. So this is the dx over dt, right? Represent the rate of change of the side, dx over dt. So we know is 0.2 centimeter per second. This is a positive, right? We put a positive because of what? Increasing. Because of increasing, so this is positive here. Don't put negative, it's a positive. So normally we don't write positive lah. We can just write that this is considered positive already, right? So I would like to find what? I want to find dv over dt, right? The rate of change of volume. So I want to find dv over dt, right? So how to find dv over dt? So I need to find this one. Okay? So I need to have the volume of the cuboid. So according to the diagram here, what is the volume of the cuboid? Right? So according to diagram, the volume of cuboid is x times 3x. So total 3x power 3. Right? 3x cubed. Right? So this is in terms of x. The function here is in terms of x. But the question I want to find is dv over dt in terms of t. So what is the relationship between the t and the v? Right? So we can use a chain rule, right? The chain rule. So according to the chain rule, is equal to dv over dx times dx over dt. Right? dv over dx times dx over dt, right? So dx over dt is given here, right? You see, here is given, so no problem. So now we need to find dv over dx. So from here, right, from here, we find the dv over dx. So differentiate it now. So 3x power 3, differentiate it, we have 9x squared, right? 9x squared. So we know that the answer you should have 9x squared times 0.2, right? So now I need the value, a value. So what is x? I need to know the value of x. So where can you get this x from? So read the question again. Do you see that this info is given? The volume is 192 cm cube. So from there, we can find the x value. So the volume, right, given, right, 3x power 3 is equal to 192, right, from here. So x power 3 is equal to 64, right? 192 divided by 3, 64. So x is equal to 4, right? It's actually 4 cm. Right? So this is a given info from the question, right? So substitute the x equal to 4. Right? And you press a calculator, you can get the answer. So what is the answer? The answer will be 28.8 unit. So this is volume, so it will be centimeter cube per second. So this is the answer for part A, right? The rate of change problem. Okay. So if okay, then what about part B? What about part B? So part B involve what? Not only involve volume, right? It's also involve another thing, right? So what is your part B? So read the part B. I would like to find the, right, look at part B. The surface area of the cuboid is decreasing. So now, be careful, this keyword is decreasing. Okay? I would like to find the rate of change of the size of the cuboid when the volume is 192. So since given the same info, right, the volume is 192, it means this info, we will use it later, right? We are going to use this one again. Okay? So for part B, given what answer now? So you check what is a given one now for part B. Then what we are going to find? Okay. So for part B, given the surface area of the cuboid is decreasing at a rate of 16.8 centimeter square per second. So given dA, right? The surface area. I'm using A to represent the surface area over dt. Right? Why dt? Because the rate of change, right? So it's equal to 16.8 centimeter square per second. But because of decreasing this word, right? Decreasing this word, you should have a negative sign. Right? You should have a negative sign because decreasing the rate. Okay? So I would like to find the rate of change of the side. So it means I need to find dx over dt. Right? I need to find this one. What is the answer for this one? So if you compare dA over dt, dx over dt, right? You will realize that there is a formula will link them together. Right? So you will realize that the formula will link them together. So what is the formula? So this is a formula will link these two info together. Right? Will be this one. dA over dt is equal to dA over dx times dx over dt. This one is given, right? We got it given. This one we want to find, right? We want to find. So it means I need to find this one. What is dA over dx? So it means I need to find the surface area of the cuboid. Right? The surface area of the cuboid. So look at the cuboid here, right? This is your cuboid. What is the surface area here? Right? So how many faces we have? 6 faces, right? Top and bottom, and then the side, 4 sides, right? So what are the total surface area? So the top, we have 2x squared, right? The top is x squared, the bottom is x squared, base and the top, 2 ma. So 2x squared. Then we have 4 what? 4 sides. So what is the side? So what is this side? Area of this side. X times 3x ma, we have 3x squared. So we have 4 of it, so times 4. So the total area, right? Total surface area, we have 2x squared plus 12x squared. So we have 14x squared. Okay? So from here, we can find dA over dx. So differentiate with respect to x, dA over dx, we have 28x. Okay? Then substitute into here. The first one is negative 16.8. dA over dx is 28x. Then I want to find dx over dt, right? The rate of change for the side x. So what is the x again here? So according to the volume is 192 centimeter cube. So according to the info, the x should be equal to 4. So that's why we have times 4 dx over dt, right? So I want to find dx over dt. So the answer will be negative 16.8 divided by 28 times 4, 112. So that's why the dx over dt, you have a negative answer, 0.15. Unit, this is the side. Side is 1 side centimeter per second. So this is a unit. Okay. So this is the answer for part B. Okay. Answer for part B. Any question? Right. If you have any problem, you can type in the chat box. We will answer you the question. Okay. So this is question number 9 and about the rate of change problem. Okay. Now we look for the last question for our today's section. We go for the last question, question 10. Okay. Question 10. So express the x times the second derivative of the function minus 2 times the first derivative of the function plus 10 in terms of x. So you need to differentiate one by one. Okay. If you look at the question, look like the question you need to use a quotient rule, right? But if you look carefully, no need. Actually, no need to use quotient rule, right? Because what? You can simplify it. Okay? You can separate into 2 terms. You have 1 over 2x squared minus, right? So if you simplify it, you are going to have 1 over 2x power negative 2, then minus x power 3 cancel with x squared. You actually have x over 2. So it's 1 over 2 x, right? So when you find your dy dx, then it will be much easier, right? So first derivative, dy over dx, right? Differentiate the first term. We are going to have, bring the power down, then the power minus 2 minus 1, minus 3. Right? Second term, 1 over 2x. Right? So simplified it. Be careful the negative sign also. So we have negative x power negative 3 minus 1 over 2. Right? Or you can have answer negative 1 over x power 3 minus 1 over 2. Be careful the negative sign. So this is the first derivative. Second derivative. So differentiate one more time, right? Differentiate one more time. Because the second term is a constant, right? Second term is a constant, so we get 0. So we differentiate the first term. Differentiate x power negative 3. We have bring down the power. Then the power we have negative 4. Right? So negative, negative become positive. So we have 3x power negative 4. Or you can have 3 over x power 4. Okay? So substitute into the given question. Right? So it means x times the second derivative minus 2 times the first derivative plus 10. So x equal to second derivative. So x times the second derivative is 3 over x power 4. And minus 2 times the first derivative. This is my first derivative. Right? Negative 1 over x power 3 minus half plus 10. Right? So simplify it. The x cancel with x power 4. We have over power 3. Right? 3 over x power 3 minus become plus. Then minus become plus again. So 2 times half, we got 1 and plus 10. So the final answer, 3 over x power 3 plus 2 over x power 3, we have 5 over x power 3. So 10 plus 1, we have 11. So this is the answer for part A, right? For part A. Okay. So part B will be the small change, right? Small change according to the formula, right? So we have the formula for the small change or approximate change, right? In terms of x or in terms of y. So the formula involved will be delta y approximately equal to dy over dx of a times delta x, right? So this is a approximate change or small change, right? In terms of x and in terms of y. So what is a given one? So if you look at the question, what is a given one? Okay. So here x changed from 2 to 2.05. So it means I have delta x, right? Because of changes in x. So the changes in x will be the latest value minus the original value. So we have positive 0.05. And of course, I need to find the value of dy over dx when the x is at the original value. So the original value is x is equal to 2, right? So I need to find the dy over dx value when x is equal to 2. So dy over dx is this one, right? This is the dy over dx, right? dy over dx. So when x equal to 2, I have negative 1 over 8 minus 1 over 2, right? So the final answer is negative 5 over 8. Okay, substitute these two info into the formula, right? Into the formula. So we know that I need to find the small change or approximate change in y, right? So approximately equal to negative 5 over 8 times 0.05. So that's why your final answer is negative 0.03125. Right? So this is the answer for part B. Right? For part B. Okay? So if okay, then I will end my section. Right? We have go through all the application and the example question for differentiation. So thank you and all the best.
Hello everyone, good afternoon. Let us proceed to session 3, which is integration. In this chapter, there are two subtopics, which are indefinite integral and definite integral. In the beginning of the chapter, you will learn about integration is the reverse process of the differentiation. Let's say if you are given the derivative function, you can obtain the original function by performing integration. Next, we will go through some of the technique of integration. Integration of a constant, integration of a power function, integrate function that contain more than one terms, and also integration of composite function. Whereas in the subtopic definite integral, you will study that there are lower limit and upper limit for the integration, where the answer is a value. And then we will go through some of the important property of definite integral. And there are two applications, which are area under the curve and also volume of revolution. Let us proceed with some of the answering technique of selected questions. In the first question, you are given a derivative function dy dt is equal to 2 minus 4t. And you are given the condition that when t is equal to 3, y is equal to 16. And you are asked to express y in terms of t. In order to express y in terms of t, we have to integrate the derivative function dy dt. We integrate with respect to t. By applying the technique of integration, you should obtain y is equal to 2t minus, when we integrate 4t, we increase the power by 1, become 4t squared, divided by the new power. Don't forget, you have to plus the constant of integration. Simplify the function, because 4t squared over 2 will be equal to 2t squared. We would not like to leave our answer in terms of plus c. Therefore, we apply the condition when t is equal to 3, y is equal to 16. Hence, we can substitute t is equal to 3 and y is equal to 16 into the previous function. And then from here, by solving the equations, we will obtain the value of c, which is equal to 28. So, we obtain the function y in terms of t, where y is equal to 2t minus 2t squared plus 28. Let us continue with the second question. In question 2, you are given that the integral of h over 4x minus 1 to the power of 3 with respect to x is equal to 2 over 4x minus 1 to the power of n plus c, where you are given h, n, and c, they are constants. Find the value of h and of n. Before performing the integration, we try to simplify the function first. We recall back that if the exponent is in the denominator, for example, 1 over a to the power of n, we can also express it as a to the power of negative n. Similarly, for the function h over 4x minus 1 to the power of 3, we can express it as h multiply 4x minus 1 to the power of negative 3. Same goes to the right hand side, where 2 over 4x minus 1 to the power of n can be expressed as 2 multiply 4x minus 1 to the power of negative n. We change this to the negative index so that we can perform the integration easier later. For the left hand side, we recall that when we integrate the function ax plus b to the power of n, we increase the power by 1, divide by the new power. At the same time, we need to divide by the coefficient of x. So in this case, it will give you h multiply 4x minus 1 to the power of negative 2. Right? This is because negative 3 plus 1 is equal to negative 2. Then you divide by the new power, and also you divide by the coefficient of x, which is 4. At the end, we plus the constant of integration, plus c. Simplify the function, we will obtain h over negative 8. We can also express it as negative 1 over 8 multiply h, multiply 4x minus 1 to the power of negative 2 plus c. Let us compare this expression to the right hand side. So in the right hand side, the constant outside of the bracket is 2, and it will equal to negative 1 over 8 multiply h. So from here, we have the equation negative 1 over 8h is equal to 2. Therefore, h will equal to negative 16. By equating the exponent of the bracket, where you will have negative n is equal to negative 2. Therefore, n will equal to 2. So we have obtained the value of h and of n. Let us continue to question 3. In the question, you are given that a curve has a gradient function px plus 4, where p is a constant. When we say gradient function, it also means that the first derivative. So we can obtain dy dx is equal to px plus 4. Given that the maximum point of the curve is 2, 6, find the value of p. We recall back that at the maximum point, dy dx is equal to 0. So from here, we obtain the information that when x is equal to 2, dy dx is equal to 0. By substitute this information to the equation dy dx is equal to px plus 4, you will obtain 0 equal p multiplied 2 plus 4. Therefore, p is equal to negative 2. In part B, you are asked to find the equation of the curve. Since you are given dy dx is equal to px plus 4, we can replace the value of p equal to negative 2. In order to obtain the equation of the curve, we have to perform integration, where we integrate the derivative function, which is negative 2x plus 4, with respect to x. And this will give you negative x squared plus 4x. Don't forget, plus the constant of integration. You are given the maximum point is 2, 6. You can obtain the value of c by substitute x is equal to 2 and y is equal to 6 into the equation. So from here, you will obtain an equation. By solving the equation, c is equal to 2. Therefore, we rewrite the equation of the curve as y is equal to negative x squared plus 4x. Instead of plus c, we change to plus 2. Let us proceed to question 4. This question is quite similar to question 3. You are given that a curve has a gradient function kx squared minus 9, where k is a constant here. Therefore, we can also write dy dx is equal to kx squared minus 9. The tangent to the curve at the point negative 2, 6 is parallel to the straight line 3x plus y is equal to 6. Since the tangent is parallel to the straight line 3x plus y equal to 6, we can say that they have the same gradient. In order to obtain the gradient, we rearrange the equation of the straight line 3x plus y equal to 6 in the form of y is equal to mx plus c. Right, so in this case, the gradient is -3. So from here we can say that dy dx is equal to the gradient -3 at the point -2, 6. Right, so from here we obtain when x is equal to -2, dy dx is equal to -3. Substitute this information to the gradient function. We replace dy dx become -3, and also we replace x equal to -2. By solving the equation, k will be equal to 3/2. By rewriting the gradient function, we have dy dx is equal to 3/2 x squared minus 9. In order to obtain the equation of the curve, we have to perform integration. We integrate the gradient function with respect to x, which we will obtain 3/2 multiply x cubed over 3 minus 9x, don't forget, plus the constant of integration plus c. By simplifying the terms, we obtain half x cubed minus 9x plus c. Since the curve passes through the point -2, 6, we can substitute when x is equal to -2, y is equal to 6 into this equation. Therefore, c is equal to -8. By rewriting plus c become -8, we obtain the equation of the curve. Half x cubed minus 9x minus 8. Let us continue with question 5. You are given that y is equal to x squared over x minus 1. And you are given dy dx is equal to gx. You are asked to find the value of integral of 3gx with respect to x from x is equal to 2 until x is equal to 4. Since you are given that dy dx is equal to gx, we know that integration is the reverse process of differentiation. So you can also write y is equal to integral of gx with respect to x. In order to find this value, by applying the property of definite integral, when you integrate a constant multiply a function, you can write it as the constant multiply the integral of the function. So you can also write this as 3 multiply integral of gx with respect to x from x is equal to 2 until 4. Recall back that integral of gx with respect to x will give you the function y. By applying the lower limit is equal to 2 and upper limit is equal to 4, this will give 3 multiply the value of y when we substitute the lower limit and the upper limit, 2 and 4 respectively. So let us continue with the substitutions. So we substitute with the upper limit x is equal to 4 and also the lower limit x is equal to 2. We find the difference, and this will provide the value of the definite integral. Therefore, the value is equal to 4. Let us continue with question 6. In question 6, you are given that the integral of fx from x is equal to 2 until 4 is equal to -3. You are asked to find the value of integral of 3fx with respect to x from 4 to 2. First of all, we recall back that the property of the definite integral. When a constant multiply a function, the constant we can write it outside of the integral. So this will also give you 3 multiply integrate fx with respect to x from 4 to 2. However, in the question, you are given the integral is from 2 to 4. The lower limit and the upper limit, they are interchanged. So, by applying another property, We recall back that when we integrate from a to b, it also equals to negative of integral from b to a. So this will give you negative 3 multiply integrate fx with respect to x from 2 to 4. By applying the information given to you where the integral is negative 3, so we obtain negative 3 multiply negative 3. This will give you the answer of positive 9. Let us proceed to part B. In part B, you are asked to find the value of k. If integral of kx minus fx with respect to x from x is equal to 2 until 4 is equal to 15, we observe that the lower limit and upper limit are the same. We can separate the integration. The first one, integrate kx with respect to x. Since k is a constant, so we can also rewrite it as k multiply integral of x with respect to x from 2 to 4 minus integrate fx with respect to x from 2 to 4 equal to 15. We already obtained this value from the question, which is negative 3. Right, so from here we can replace it as negative of negative 3. Integrate x with respect to x will give you x squared over 2. And we have to evaluate this definite integral from 2 to 4. So, by substitute the upper limit and the lower limit, and we find the difference, right? So from here we obtain 4 squared over 2 minus 2 squared over 2. By simplifying it, we will obtain k multiply 6, or we can also write it as 6k plus 3 equal to 15. By solving this equation, you should obtain k is equal to 2. Let us continue with question 7. In question 7, it involves the application of integration, area bounded by the curve. In diagram 7, there is a shaded region bounded by the curve y equal to gx, the x-axis, and also the straight line x is equal to 2. You are also given that the area of the shaded region is 15 and 1/3 unit squared. Part A. Find Part 1. The integral of gx with respect to x from 0 to 2. From diagram 7, you observe that the curve y is equal to gx is below the x-axis. Therefore, the integral from 0 to 2 will give you a negative answer of the area. So from here, we obtain the answer negative 15 and 1/3. Part 2. You are asked to find the integral of x minus 3 multiply gx with respect to x from 0 to 2. We integrate it term by term. So from here, integrate x with respect to x will give you x squared over 2 minus 3 multiply the integral of gx with respect to x. By substituting the lower limit and upper limit and find their difference, we obtain x squared over 2 become 2 squared over 2 minus 0 minus 3, where the integral of gx with respect to x from 0 to 2, we already obtained the answer in part 1, which is negative 15 and 1/3. Therefore, this will give you the answer 48. Let us continue with part B. In part B, you are given the gradient function g prime x is equal to 2x minus 5. Find gx in terms of x. In order to obtain gx from the derivative function, we have to perform the integration. We integrate 2x minus 5 with respect to x. This will give you x squared minus 5x plus c. In order to obtain the value of the constant c, from diagram 7, we realize that negative 4 is the y-intercept of y is equal to gx, which means that it will pass us through the point 0, negative 4. So we replace when x is equal to 0, gx is equal to negative 4. So this will give you an equation, c will equal to negative 4. So we obtain the function gx in terms of x. where gx is equal to x squared minus 5x minus 4. Let's continue with question 8. In question 8, diagram 8 shows the curve y is equal to x squared plus 4 over x squared. The straight line PR is tangent to the curve at point Q, where the coordinate of Q is 2, 2. Find the equation of the straight line PR. From the diagram, the straight line PR is also same as the tangent to the curve at the point Q. Therefore, in order to find the equation of the straight line, we have to first determine the gradient, where the gradient of the tangent to the curve can be obtained by using the derivative dy dx. So first, we have to differentiate the function y. Instead of using the quotient rule, I will first simplify the function first. We have x squared over x squared is equal to 1. 4 over x squared is equal to 4x to the power of negative 2. So, dy dx will equal to negative 8 x to the power of negative 3. By simplifying it, you can also rewrite it as negative 8 over x cubed. To obtain the gradient of the straight line, we substitute the value of x is equal to 2 into dy dx. So this will give you gradient is equal to negative 1. By applying the equation of the straight line, where y minus the y coordinate of q is equal to the gradient multiply x minus the x coordinate of q. By expanding the bracket on the right hand side, this will give you negative x plus 2. Rearrange it, you will get the equation of the straight line, which is y is equal to negative x plus 4. Let us proceed to part B. In part B, you are asked to find the area of the shaded region, where the area of the shaded region is bounded by the curve, bounded by the straight line PR, x equal to 6, and also the x-axis. In order to obtain the area of the shaded region, I will consider the area under the graph from x is equal to 2 until x is equal to 6, minus the area of triangle, where the red region is the triangle. In order to find the area of the triangle, we need to have the base and the height. So from the coordinate of Q, we already have the height is equal to 2 units. In order to find the base, we have to first find the x coordinate of R. So at point R, it is on the x-axis. So from here, we say y is equal to 0. So by substitute y equal to 0 into the equation of the straight line in part A just now, we obtain x is equal to 4. So we will have the base of the triangle will be equal to 2, because 4 minus 2 is equal to 2. Let us continue to find the area of the shaded region. For the area under the curve, we have to integrate x squared plus 4 over x squared. Where you simplify it, it will become 1 plus 4x to the power of negative 2. So this will give you x plus 4x to the power of negative 1 over negative 1. We have to evaluate the integral by substituting x equal to 2 and also 6. For the area of the triangle, we have negative half, multiply the base, which is 2 units, multiply the height, which is also 2 units. Right, simplify the integral and continue with the evaluation. Then you will obtain the area of the shaded region is equal to 3 and 1/3 units squared. Let us proceed to question 9. In diagram 9, you are given a straight line y is equal to x minus 4. And the straight line intersect the curve x is equal to 1 over 4 y squared plus 1 at the point A. So in the diagram, this is point A. Find the coordinate of A. In order to find the coordinate of A, we have to solve the simultaneous equation. So at point A, for the equation of the straight line, I will rewrite it as x is equal to y plus 4. Whereas for the curve, x is equal to 1 over 4 y squared plus 1. By equating these two equations, because both of the left hand side are x, so y plus 4 is equal to 1 over 4 y squared plus 1. Since this is a quadratic equation, I will write it in the general form. By multiplying negative 4 on each of the term, you will obtain y squared minus 4y minus 12 is equal to 0. By factorization, you will have y plus 2 multiply y minus 6 is equal to 0. So there are two roots for this equation, where y is equal to negative 2 or y is equal to 6. However, in diagram 9, point A is below the x-axis. If the point is below the x-axis, the y coordinate should be a negative value. Therefore, we reject y is equal to 6. So the only value of y will be negative 2. By substituting y is equal to negative 2 in either one of the equation 1 or equation 2, we obtain the value of x, where x is equal to 2. Therefore, the coordinate of A will be 2, negative 2. Let us proceed to part B. In part B, part 1, calculate the area of the shaded region P. From the diagram, region P is bounded by the x-axis, y-axis, the curve, and also the straight line. In order to find the area of the shaded region, I will split the shaded region into two parts, where the first part is the region bounded by the curve with respect to the y-axis from y is equal to negative 2 until the x-axis. Another region will be a triangle. So this will give you the integral of 1 over 4 y squared plus 1 from y is equal to negative 2 as the lower limit, and also the x-axis, which is y is equal to 0 as the upper limit. And we have to add with the area of the triangle, which is from negative 2 until the y-intercept of the straight line. From the equation of the straight line, which is y is equal to x minus 4, the y-intercept of the straight line shall be negative 4. So this gives you the height of the triangle as 2 units, and also the base of the triangle 2 units. So by performing the integration, it will give you y cubed over 12 plus y. And then you have to evaluate the integral, where the area of the triangle is half multiply the base 2 units and also the height 2 units. Therefore, by evaluate the integral added along with the area of the triangle 2 units square, this will give you the answer 4 and 2 over 3 units square. Let us proceed to part 2. You are asked to find the volume of the revolution in terms of pi when the shaded region Q is rotated through 360 degrees about the x-axis. So it will form a solid as shown here when it is rotated through 360 degrees about the x-axis. By applying the formula that the volume of revolution is integral of pi y squared dx, this is because the rotation is about the x-axis. So we have to rearrange the equation of the curve. Instead of x is equal to 1 over 4 y squared plus 1, we have to write it as y squared is equal to 4 multiply x minus 1. So this gives the volume of revolution as integral of 4x multiply x minus 1 from x is equal to 1 until 2. This is because at the x-axis, y is equal to 0, When y is equal to 0, x is equal to 1. This is the lower limit. And the upper limit is 2, where you have the x coordinate of a is equal to 2. Since 4x is a constant, so we can remain it. Integrate x minus 1 with respect to x will give you x squared over 2 minus x. We have to evaluate the integral by substituting the lower limit x is equal to 1 and also the upper limit x is equal to 2. This will give you the answer 2 pi unit cube as the volume of the revolution. Since the question mentioned in terms of pi, so we remain our final answer in terms of pi. We will continue to the last question, question 10. In this question, diagram 10 shows the curve y is equal to x squared plus 1. This is the curve. Intersect the y-axis at point A. So point A is the y-intercept of the curve. And also the straight line y is equal to 4 minus 2x at point B. Find the coordinate of point A. To find the coordinate of point A, at point A, it is on the y-axis, so x is equal to 0. So we substitute x is equal to 0 into the equation of the curve. We obtain y is equal to 1. So the coordinate of point A is 0, 1. Let us proceed to part B. Find the area of the shaded region R. In shaded region R, it is bounded by the curve, by the straight line, the x-axis, and also the y-axis. In order to find the area, I will split it into two parts. The first part is the area under the curve from x is equal to 0 until x is equal to 1. And also the triangle from x is equal to 1 until x is equal to this part. So we have to find the x-intercept based on the equation of the straight line. So the area under the curve is the integral of x squared plus 1 with respect to x from 0 to 1, added along with the area of the triangle. By integrating it, you will obtain x cubed over 3 plus x. Later, we need to evaluate the integral where the lower limit and upper limit are 0 and 1 respectively. Whereas for the area of the triangle, we have half multiply the base multiply the height. So for the base, from the equation of the straight line, y is equal to 4 minus 2x. At the x-axis, y is equal to 0. So when 0 is equal to 4 minus 2x, x is equal to 2. So the base is equal to 2 minus 1, which is also equal to 1 unit. Whereas the height is the y-coordinate of point B, which is 2 unit. So you have half multiply 1 multiply 2 as the area of the triangle. By doing further calculation, we will obtain the area of the shaded region is equal to 2 and 1/3 unit square. Let us proceed to part C. In part C, you are asked to find the volume generated in terms of pi when the region bounded by the curve y is equal to x squared plus 1, the straight line y is equal to 2, and also the y-axis is revolved through 180 degrees about the y-axis. From the information given by the question, the region is not region R. So we shouldn't assume that we are going to generate the volume based on the region R, but we have to find the region required by the question. The region bounded by the curve y is equal to x squared plus 1, the straight line y is equal to 2. Since you are given point B where the coordinate is 1, 2, the straight line y is equal to 2 is a horizontal line that passes through point B. And the y-axis is this region. And this region is revolved through 180 degrees about the y-axis. When we find the volume generated, we know that this is integral of pi x squared with respect to y. However, we need to multiply by half, where this 1 over 2 is come from 180 degrees divided by 360 degrees. It is not a complete revolution, but just half of it. From the equation of the curve y is equal to x squared plus 1, by rearrange it, you will obtain x squared is equal to y minus 1. By performing the integration, you will have pi multiply y squared over 2 minus y. We have to evaluate the integral by substitute the lower limit y is equal to 1 and the upper limit y is equal to 2. After that, we have to multiply by half. So by performing the calculation, this will give the answer pi over 4 unit cube, or you can also write it as 1 over 4 multiply pi unit cube. That's all for the session. Thank you.
All right, guys, so that's the end of our session. We hope that you gain as much as possible all the information that has been shared to you throughout these 4 hours, right? And apply whichever possible in your examinations next year. All right. Okay, so let me share my screen for a while. I would like to remind you on our session next, right? So later 2 p.m. we will have English writing for SPM paper 2. Yesterday we covered paper 1. For those who already registered for this one, okay, you can join us later. Okay, and if let's say you would like to contact us, you can get in touch with us through several methods. You can go to our Facebook. If you have not liked our Facebook yet, you can go and visit our Facebook page and like it. Utah for you. You can reach us through our mobile. You can WhatsApp us. You can call us. You can also WeChat us. And you can go to our website at study.utah.edu.my. Eventually, we have our live chat officer will be ready from 9 a.m. to 5 p.m. daily, who will entertain you. And if let's say you like to drop us an email, you can go to inquiry@utah.edu.my. Okay, so again, for those who will join us later, I'll see you soon. And for those who are not, we just would like to wish you good luck in your SPM next year. Okay, stay safe and stay healthy. We'll see you soon in future. Okay, bye-bye.